Hello students, welcome to the class. So today is our day 14 of this JEE 40 days crash course, and we will be covering the last part of this ionic equilibrium, and I would say the last part of equilibrium. So far we have covered this physical and chemical equilibrium, and in the ionic equilibrium part we have seen the electrolytes. Okay, what are weak electrolytes, what are strong electrolytes, and how do we define their dissociation constant, which is Ka and Kb for acids and bases respectively. Now in today's class our focus will be mainly on one thing, which is calculation of pH. Now in that thing we have three parts. So there are three conditions in which we need to calculate pH. First is the buffer solution, second is the salt hydrolysis, and third is the case of normal acidic or basic solution. So I would say today will be an important class from the exam point of view. Please join the class so we can begin our class in few minutes. So it is already 4:01. We will begin our class in 4:05. If you have a doubt from the previous class, you can ask it here right now in the comment section. So can you just please send a hi if you are attending the class, so that I can see how many of you are present here. Please just send a hi in the comment section so that I can get a notice of how many of you are attending the class. So this will be our day 14, right? In tomorrow's class we will see the redox reaction. So this will be the last class for the equilibrium chapter. So this is our disclaimer. Now what are the topics that we are going to cover today? So please send a hi so that I can get a overview of how many of you are attending the class. So first thing that we are going to see is the relation between acid and base dissociation. Okay, so we will see that thing in terms of Ka and Kb. Next we will study about pH scale. Then after we will learn about hydrolysis of salt and see how hydrolysis of salt affects the pH of a given solution. So from your previous knowledge also in the 9th and 10th class, you must have studied that salts are also acidic and basic in nature. Okay, so if you are taking a strong acid and a weak base, then the resulting salt will be an acidic salt. Similarly, if you take a weak acid and a strong base, then the resulting salt will be a basic salt. Okay, so this is the thing that you must have studied in your previous class, but there we didn't see that how to calculate the pH of such salts where it is acidic or basic in nature. So today we will see a formula to calculate the same. Next we will see the solubility of sparingly soluble salt. Now what is sparingly? Sparingly means which is slightly soluble. Okay, in simple terms I would say which is slightly soluble in nature. For example, if you take your oil and try to dissolve it in water, it is insoluble. So that is the case of no solubility. If you dissolve NaCl, it will be completely soluble. Whereas if you take salt like barium sulfate, then it will be partially soluble, or I would say it will be sparingly soluble. Means the amount of salt which will go into the water will be very less. Then next we will see solubility product. So solubility product is an important concept which is related to sparingly soluble salt. Got it? Then we will move on to common ion effect. So I have already given you a glimpse of this common ion effect. So basically when in a solution two electrolytes are giving the same type of ion, then a phenomena which is known as common ion effect is shown there. After that we will move on to buffer solution. So from our basic point of view, we know that buffer solutions are those solutions which resist the pH change. Okay, so if you add a small amount of an acid or a base in a buffer solution, then it will not change, or it will not allow the solution to change its pH. We will see how that buffer solution works and how do we calculate the pH of that buffer solution. Then after, we will move on to the pH calculation formula used in the buffer solution, which is known as Henderson's Henselbach equation. Lastly, we will see the buffer capacity. So these are the topics that we are going to cover today. I would say the most important part is your pH calculation, and under the pH calculation we have hydrolysis salt, then we have common ion effect, then we have Henderson's Henselbach equation. So this is all about our today's class, starting with the first part, which is relation between Ka and Kb. Now what is K? K is acid dissociation constant. So whenever a weak acid dissociates, you represent its equilibrium constant in terms of acid dissociation constant, which is K. Similarly, in the case of base, we use the Kb notation for the base dissociation constant. Now, what is the relation between these two? Remember, this relation is only valid for conjugate acid-base pair. Let me explain it. So first of all, I would request you to write it down that what is the reaction result of HA and H2O, where HA is an arbitrary acid and H2O is your water. So when you react HA and H2O, what will be the outcome? Just write the chemical equation for that. Remember, since it is an acid, it will donate one H plus to the water. And why will water accept it? Because water is amphoteric in nature. It can act both as an acid and base. Okay. So what will be the outcome if you react your HA and H2O? Can anyone tell it? So I am trying to explain that how is this formula applicable to only a specific case. So for that, you must know that what will be the outcome for the reaction of an acid which is written as HA with H2O. What you will get as your product? Anyone, can you tell me? Remember, HA is an acid, so it will donate one H plus to the H2O. So please comment it in the comment section. Anyone, can you tell me what is the outcome for the reaction of an acid which is HA with water, which is H2O? So I am waiting for your response. Please comment it down. What will be the outcome for the reaction of HA with H2O? Remember, this is an acid-base reaction. Your HA will donate one proton to H2O and it will form A minus and H3O plus. Okay. Now, if you write K, which is acid dissociation constant for that particular reaction, then it would be the concentration of A minus multiplied by the concentration of H3O plus divided by the concentration of HA. Got it? So this will be your Ka. Similarly, that same acid that you have taken, you take the conjugate base of that. So if HA is the acid, the conjugate base will be A minus. Very good, Patham. Yes, it will give you H3O plus and A minus. Got it? Now, if you take this A minus and react that A minus with H2O again. So basically you have to write the reverse reaction. So in that case, your A minus will act as a base. Right? A minus will act as a base and it will take one proton from water to form HA and OH minus. Got it? So there are two reactions now. In the first case, your HA is reacting with water to form A minus and H3O plus. And your A minus, which is the product, it can again react with water to form OH minus and HA. In the first case, your HA is acting as an acid, and in the second case, your A minus will act as a base. So, for both of these reactions, you can write your Ka and Kb. Got it? Now, if you multiply K and Kb, you will get your Kw. So what we can conclude from here is that this formula is only applicable to those species which are an acid base pair or a conjugate acid base pair. For example, if I say that what is the way to apply it on CH3COOH, so you can only apply it to Ka of CH3COOH and Kb of CH3COO minus, and the multiplication of both of them will give you Kw. I hope you got my point if you have written it down. Now, if you just take the negative logarithm throughout the equation, so if you take minus log here and minus log here, you will get it as pKa plus pKb is equals to pKw, where log minus log Ka is pK, minus log Kb is pKb, and minus log Kw is pKw. Moving on to the next type of species, which is known as polybasic or polyprotic acids. Now, what do you mean by that? So, such species which can donate more than one proton are named as polybasic or polyprotic. For example, if you take H2SO4, which is having two ionizable proton, so in that case you can call it as polybasic or polyprotic acid. Similarly, if you take a base which has more than one OH minus available, for example, if you take calcium hydroxide, so it can donate 2 OH minus, so in that case it will be polyacidic in nature. Now, for these type of species, always remember the first dissociation constant will be greater than the second dissociation constant. Now, what is the first and the second dissociation constant? For example, if you take H2SO4, it can dissociate as H plus and HSO4 minus. If you write Ka1, okay, if you write the acid dissociation constant for that species, it will be Ka1. Similarly, if you just try to further dissociate your HSO4 minus into SO4 2 minus and H plus, it will be written as Ka2. Now, Ka1 will be always greater than Ka2. What is the reason behind that? The reason is that when you are removing the first proton from H2SO4, your H2SO4 is a neutral species. So, it will easily donate its H plus to the solution. But when you are removing it from the H2SO4 second time, that means you are removing it from HSO4 minus. So, HSO4 minus is already an ionic species which is carrying a negative charge. If you try to remove one more H plus from it, it will again result in 2 negative charge. Okay, so that is something which is making your molecule more unstable, and hence it is difficult to remove the second proton as compared to the first proton in case of polybasic acids such as H2SO4 or H3PO4, and that is the reason the extent of dissociation is more, and hence Ka1 is greater than the Ka2. Okay, any doubt in this part? If you have a doubt, you can ask it. So what did we study? So we saw that for a conjugate acid base pair such as CH3COOH and CH3COO minus, the multiplication of K and Kb is equals to Kw. If you take the negative logarithm further, you will get it as pKa plus pKb is equals to pKw. Then we saw that for polybasic acids or for polyprotic acid which have more than one ionizable proton, they can have two dissociation constant Ka1 and Ka2, and Ka1 will be always greater than Ka2. I hope this is clear to all of you. Now, moving on to the next part. So, we have already read about this, that the summation of pH and pOH is equals to the 14, okay, which is your pKw value, and this thing is only valid at 25 degrees Celsius. Now, what is pH? So, pH is the negative logarithm of H3O plus or H plus. You can call it both because the H plus species is taken as the initial species. As soon as you put it in water or as soon as it is released in water, it completely forms the H3O plus, because H plus is very less stable or highly unstable. So, we can say that the negative logarithm of H3O plus or your H plus is equals to pH. Similarly, the negative logarithm of OH minus is equals to pOH. Now, if you add both of them at 25 degrees Celsius, its value is equals to 14. So, pH plus pOH is equals to 14 at 25 degrees Celsius. This value will decrease if you increase the temperature. Got it? What it will do? It will decrease, it will not increase. Why? Because if your H plus will increase, your minus log will decrease because we have a negative sign here. That means your pH will decrease. Similarly, if your OH minus concentration will increase on increasing the temperature, your minus log OH minus will decrease and hence your pOH will decrease. If both of them are decreasing on increasing the temperature, so the overall value, the addition of both of them will also have a lower value at higher temperature. Now, we saw this relation earlier. So pKa plus pKb is equals to pKw. Now we can call that at 25 degrees Celsius, this summation is equals to 40. Okay. So your pH scale is ranging from 0 to 14 depending on the value of Kw. Now following observations are seen with the solution. First of all, pH of very dilute solution, acids or base, is nearly equal to 7. Okay, but not 7 due to ionization of water. So whenever you are taking a weak acid, then you will observe that its pH is equals to 7, but it is not true. Why? Because when we are taking a lower concentration of a weak acid, then the contribution from water cannot be neglected. Okay, in case of strong acid, we neglect the water's concentration, which is giving the H plus. But in case of a very small amount of acid, we have to include the water's contribution as well. So if you do that, then and then only you will get your correct answer. Then after, your pH of strong acids with concentration greater than 1 molar is never negative. It will be 0 only. Last one, K or Kb, smaller is the value of pKa and pKb. So if you are taking a stronger acid, that means its pKa value will be less and Ka value will be large. And what is the reason? Straightforward, you take the formula. So pKa is equals to minus log Ka. So you are taking a negative logarithm of Ka. So if you are having a strong acid, more will be the extent of dissociation and more will be the Ka. Got it? But lesser will be the pKa. So if you are comparing two acids, the acid which has a larger value of pKa will be a weak acid. Okay, so this point is very, very important for your organic also. You will see this thing there. Next, as I said earlier, so our main focus will be on pH calculation. So I will put various conditions in which you have to calculate pH. First condition, if you take acid and base, right? If you take a mixture of acid and base and you see that you are combining both of them and you are getting strong acid which is unused or strong base which is unused, then in that case the concentration of H plus and OH minus will be simply deciding factor for the pH and pOH. So I have a question here. If Ka is larger than pK, then it is acid. So I didn't get your question. Can you just repeat it once more? Okay, just write it once more. I didn't get your question. Now, coming back to our thing, I said that if you are taking a strong acid in a strong base and reacting it with a weak acid in a weak base, after the whole reaction, your strong acid is still left in the solution, means it was present in excess. Then in that case, you calculate the pH by simply calculating the concentration of H plus and OH minus and taking the negative logarithm of that. So this is the first condition. The second condition is that if you are taking a weak acid or a weak base and reacting it with a strong acid or any other acid, but after reaction, your weak acid is left in the solution. Okay, in the first condition, your strong acid or strong base was left in the solution. In this condition, your weak acid or weak base is left in the solution. In that case, you have to apply the buffer formula to calculate the pH. Okay, so first condition, you are reacting an acid and a base and your stronger acid or stronger base is left in the solution, then in that case you calculate the pH by simply using the H plus and OH minus concentration. In the second case, if you are reacting two acid and a base and you are seeing that weak acid or weak base is left behind in the solution, then you use the buffer formula. If K is large value and pK has small value, then it is acid. Yes, it is acid. Of course, it is an acid. Now, let me give you a broader point here. So, acid and bases. So, this is a relative term. Okay, in our daily life, we put a constant that this is a acid or this is a base. Okay, and in your 12th class also you will see this. But when you will move to higher class, you will see that this acid and base is a relative thing. Suppose you take a very strong acid, okay, and react it with the acetic acid. Then in that case, you will observe that your acetic acid will act as a base. So it will totally depend upon the other species with which you are reacting it. Okay. So to put a stamp on it that it is an acid or it is a base is a wrong thing, I would say. Got it? Now, moving on to the next point. In the case where your complete neutralization is taking place, then in that case you have to use the hydrolysis equation. So three situations are there. In the first situation, if you are left with strong acid or strong base into the solution, then in that case you will simply use the H plus and OH minus concentration to calculate the pH or pOH. In the second condition, after the neutralization process, if you see that some part of your weak acid or weak base is left in the solution along with the salt, then in that case you will apply the buffer formula. In the third case, if there is complete neutralization, then you will use the hydrolysis of salt or hydrolysis equation to calculate the pH. I hope this is clear to you. Now next, moving on to our next thing, which is effect of temperature on pH. As I said earlier, that if you increase the temperature, then dissociation will be higher, and for acids you will get more number of H plus or higher concentration of H plus. If H plus concentration will increase, that means pH will decrease. Okay. For example, if you take the pH of boiling water, so boiling of water takes place at 100 degrees Celsius. So at 100 degrees Celsius, your pH of water is 6.5. If you compare it with the neutral case, which is your pH at neutral condition, you will find that the pH is equals to 7. But pH of your boiling water is equals to 6.5. So you can see how your temperature is affecting the H plus concentration, and in turn it is affecting the pH as well. So this is clearly indicating that your H plus concentration has increased because your pH concentration has gone, value has gone down. Next, what is the significance of pH? Why we are using pH, and how can we imagine the effect of change of pH? So it's a very large change when you are changing your pH by even 1 unit. Suppose you change your pH by 1 unit, then your acidity is increased by a factor of 10. Okay, because you are taking a log of that. Similarly, if you are increasing your pH by 2 unit, suppose your pH was initially 7, now you are making it 9, then the concentration change is very, very large. For example, if you are decreasing your pH from 7 to 5, then H plus concentration is increased by a factor of 100 times. So you can see that how much large effect can be on your solution if you change pH by a unit also. Any doubt till this point? Anyone? Who has a doubt till this point? So this is the most important slide, I would say, in your whole ionic equilibrium, where you will see that how can we calculate pH in various situations. So if you have a doubt, you can ask it in the comment section. Partham, Dhruv, VK. If you are attending the class, if you have a doubt, you can ask it, or anyone. Gagan Garg, if you have a doubt, you can ask it here. What is pH and pOH calculation in different cases? So we have three situations here. The first situation is that you take a combination of an acid and a base. Then if your strong acid or strong base is left into the solution, then in that case you will simply calculate the H plus concentration and OH minus concentration which is left, and from there you can calculate your pH and pOH accordingly. Second condition, if you are using a weak acid and a weak base, and after the neutralization process, your weak acid or weak base was excess in the solution, then in that case, your buffer will be formed and you will use the Henderson-Hasselbalch equation, which I will show you in the next slide, upcoming slide. You will use the Henderson-Hasselbalch equation to calculate the pH. In the third situation, if you have complete neutralization, okay, so in the first two situations we are not facing complete neutralization. Suppose you have a complete neutralization, in that case we have to use the hydrolysis of salt. So in one condition the hydrolysis of salt is also not applied in case of complete neutralization. So that is the case of taking a strong acid and a strong base. So if your salt is formed from a strong acid and strong base and there is complete neutralization also, in that case your hydrolysis is not applicable, and we will see that. So if you have a doubt in this part, you can ask here or we can move further. Anyone who has a doubt? Gagan Garg, Partham, VK. Okay, so I will assume that you all got my point. So moving on further. Next, we have hydrolysis of salt. So this is our first part. So where do we use hydrolysis of salt? Where there is a complete neutralization. Got it? So what is salt hydrolysis? It is actually the reverse process of neutralization. So if you are reacting a weak acid or a weak base, then after complete neutralization, your salt will be present in ionic form. For example, if you are reacting NaOH and CH3COOH. So after the complete neutralization means all the NaOH and CH3OH have react completely to form the sodium acetate, which is CH3COO minus Na plus. Got it? So in that case, your salt will be present in ionic form in the water solution. Now, your Na plus has no effect on the pH, but your acetate ion, which is CH3COO minus, it will increase the pH. Why it will increase the pH? Or you would say it will decrease the acidity, because your acetate ion will take H plus ion from the water solution. You know it very well that water is still dissociating to a very small extent. Now your acetic acid will take that small amount of H plus, and you know that it is a weak electrolyte, so it will not go in the further direction. It will take that H plus and it will remain in the undissociated form. As a result of reducing the H plus or taking off H plus by acetate ion, your equilibrium will be disturbed in the solution. Now to counter that, more H2O will dissociate and more OH minus will be released. Okay. So basically, in this case, you would see that you have a neutral solution. So you have your H plus and you have your OH minus. As soon as you introduce a salt of weak acid and a strong base, your weak acid is your acetic acid and your strong base is your sodium hydroxide. Now your acetate ion from the acetic acid will take the H plus, but OH minus will be in the solution, and that will increase the pH, or I would say that will make your solution basic. Similarly, you can try to understand it for the basic salt, where you will take a strong base and a weak acid. Okay. Now, as I said earlier, you have a strong acid and a strong base. That in that case, your hydrolysis is not possible. So it is only possible when one of the species is weak or both are weak. Then and then only your salt hydrolysis is possible. In case of salts formed from strong acids and strong base, your pH will be equals to 7. So if you are taking NaCl, which is a salt of strong acid and strong base, NaOH and HCl, it will form a neutral salt, which is having a pH of 7. Similarly, if you take calcium hydroxide, which is a strong base And H2SO4, which is a strong acid, it will again form a neutral salt of pH 7. Okay, so salt hydrolysis is not applicable to salts of strong acids and strong bases. But if you take a strong acid and a weak base, then in that case, you will always get a acidic salt. So whichever is stronger, so that will decide your pH. Since we are taking a strong acid, so pH will be less than 7 because the salt formed is acidic in nature. For example, NH4Cl is formed from NH4OH and HCl. NH4OH is a weak base, ammonium hydroxide, and HCl is a strong acid. Therefore, your salt will be acidic in nature. Now, in such cases, how do you calculate the pH? It's very simple. First of all, you calculate the H plus concentration or H3O plus concentration, which is root under KH into C. Now you will ask, how will calculate KH? It's very simple. It is KW by KB. Or you can substitute this in the previous equation and directly calculate the pH from this formula, which is pH is equals to 7 minus half pKb plus log C, where Kb is the base dissociation constant for the weak base. So salt is formed from a strong acid and a weak base. This weak base will of course have a Kb value. From that we can calculate the pKb, or if pKb is directly given, you can use that also. And hence you can calculate the pH. Now what is C here? This C is the concentration of your salt. Okay. Next, what is KH? KH is the hydrolysis constant. Kb is the ionization constant or dissociation constant for the weak base. Then we have C, which is the molar concentration of salt. So we have seen two cases. In one case, we have strong acid and strong base. In that case, if complete neutralization is occurring, then pH will remain 7. If complete neutralization is occurring in the case of strong acid and weak base, then pH is calculated using the formula 7 minus half pKb plus log C, and KH is calculated using the formula KW by KB. What is the next situation we can imagine? The next situation is of a strong base and weak acid. So we are taking the opposite case here. Now, in this case, your base is strong. So your salt will be basic in nature. And in this case, your pH will be more than 7 since it is a basic solution. And to calculate the OH minus concentration, you will use that same formula. But KH formula will be changed. Okay? Because now we have a weak acid and not a weak base. So KH will be KW by KA. Because for strong base, it does not make any sense to have a dissociation constant because there is a complete dissociation there. Next, what is the formula to calculate pH? Only a small change is there. What is that small change? So in the previous formula, we have 7 minus half pKb plus log C. Here we are replacing plus with minus and pKa with pKb. Okay, so this is the small change you can do, and you can get your formula for calculation of pH in case of strong base and weak acid. Any doubt in this part? Now, what is the fourth case? First case, strong acid, strong base, both will have the same thing. Therefore, in that case, your pH will be 7. Second case, we will have strong acid and weak base. So, there the formula is pH is equals to 7 minus half pKb plus log C. Third, this case where we have a strong base and a weak acid. So, pH will be 7 plus half pK plus log C. The last case is of weak acid and weak base. So, both are weak in nature. In that case, your hydrolysis will surely take place and you will calculate the KH by a formula KW by K into KB. So in the first one, you used KW by KB where we have a weak base. In this one, we have a weak acid, but here both are weak. So you will use KW by K into KB. Easy to get? Now, how do you calculate pH? So pH is half plus pKb in the right side and pK in the left side. So pKa minus pKb. So this is your formula to calculate pH in the case of a salt which is formed from weak acid in weak base. Now you will ask, what will be the nature of salt? Whether it will be acidic salt or basic salt. So that will depend upon the strength of acid or base you are taking. The weak acid or weak base if you are taking. If your weak acid is strong enough to counter the weak base, then your salt will be acidic in nature. If your weak base is strong enough, then in that case you will see that your given salt will be basic in nature. Okay, is it clear to all of you? Any doubt in this part? So this is a very important formula which is used in the calculation of pH if you are getting a complete neutralization. So we have seen 4 cases and 4 formulas. Any doubt in this part? So this will be used in your calculations as well when you will do the PYQs in our question part. Now, a very important point to note. So it says that your effect of dilution on hydrolysis of salt of weak acid and weak base has no effect on the pH and KH. How can we say that? Because KH has no concentration term. Okay. See, in the case of OH minus, concentration was used here to calculate the pH or pOH. Very simple. And similarly, we can see it in the case of your weak base and strong acid. But here, if you see that what is the formula to calculate the pH, it is 7 plus half pK minus pKb. So no matter what concentration you are taking for the salt, it will have no effect on the pH calculation because there is no concentration term in the pH formula. Yes, if you are attending the lecture, if you are doing our DPPs on time, and if you are attending all the PYQs, then you will surely crack this exam in the chemistry part, right? And in the physics and maths as well. Okay. So you have to attend the class, do the DPPs, and do the PYQs along with us. Next, solubility of sparingly soluble salt. So now we are moving on to sparingly solubility of salt. So dependence of solubility of salts is there on the solvation enthalpy. So this is the part of thermodynamics where we saw that if your molecule after dissociation is giving enough energy so that your molecule can be broken or your solid can be broken into particular species, then your solvation is possible. But in case of sparingly soluble salt, this dissociation is up to a very small extent and a equilibrium is reached between the dissociated and undissociated part. Now, next thing which is related to this sparingly soluble salt is your solubility product constant. It is defined as the product of molar concentration of its ion in a saturated solution, where your each concentration term is raised to the power which is equals to the number of ion produced on dissociation of one molecule of electrolyte. So let me break it down with the help of an example. Suppose you are taking a salt which is AXBY. Now, if it will be released in water, then it will be broken into XA plus and YB minus, means X moles of A and Y moles of B minus. Then, how do you calculate the KSP? Don't worry, Parth. If you will do the preparations along with us, surely you will able to crack the JEE exam. Okay? Don't worry. Now next, what will be the KSP formula? If this is the salt, remember this is very important. So it is simply the concentration of A plus raised to the power X, since X is the stoichiometric coefficient. Then B minus concentration raised to the power Y, which is the stoichiometric coefficient of B minus. And this will give you your KSP value known as the solubility product constant. Now, let me take an example. Suppose we are taking a salt whose general formula is A2X3. Okay, so rather than taking an arbitrary coefficient, we are taking a specific coefficient which is 2 and 3. Now, if S, which is the solubility, or you can also tell it as the concentration of the salt. Okay, so this is the concentration of A2X3 salt. Now, when it will be dissociated in water, 1 mole of your A2X3 will give 2 moles of A3 plus. So, if S is the concentration of A, then 2S amount will be given in the solution for A. Similarly, 3S amount will be given in the solution for X. So, this will be the corresponding concentration when you dissolve your A2X3 into the water. Next, how do you calculate KSP? I said it earlier, you have to take the concentration of A3 plus and raise it to the power which is equals to the stoichiometric coefficient. Similarly, you will do it for the X. Now, what is the concentration of A3 plus? We said that 1 mole of A2X3 is dissolved in water. So, that will give you 2S as the concentration of A. So, in place of A3 plus concentration, you will write it here 2S, 2S square. Similarly, for X2 minus concentration, you will write it as 3S cube. Got it? So, this is directly coming from this equation. Now, if you just solve it further, you can simplify it to KSP is equals to 108 S to the power 5. So, 2 square means 4 and 3 cube is 27. 27 into 4 is 100 S raised to the power 5. What is S here? So, S will be the solubility of the salt, your sparingly soluble salt. Any confusion in this formula? So, this is very important formula and an easy one. Questions are asked from this part. Okay. Anyone who has a doubt in this? So, you can ask your doubt here. Still, if you are facing any difficulty, you can just come to our doubt clearing session, which is held from 10 a.m. to 6 p.m. And then you can post your questions also on our SATHEE forum. Anyone who has a doubt in this part? How do you calculate KSP? So, this is the general formula. Now, we will apply it specifically to a example. Anyone who has a doubt? Gagan Garg, Partham, Dhruv. Okay. So, I hope this is clear to all of you. Now, moving on further, we will take a specific example, and that specific example will be of barium sulfate. Got it? Suppose S is the solubility of your barium sulfate. Now, your stoichiometric coefficient will be 1, 1 for each of them because barium sulfate is present in 1:1 ratio. So, if S is the concentration of barium sulfate, then it will give you S amount of Ba2 plus and S amount of SO4 2 minus. Got it? Now, what will be the KSP? We will take the concentration of barium sulfate multiplied by the concentration of SO4 2 minus. Remember, this is only true when your given solution mixture is in equilibrium condition. Okay, then and then only you can apply this solubility product constant calculation. Now, if you put the value of your concentrations, you will get it as S square, where S is the molar solubility or simply the concentration and KSP is the solubility product. Now, if you calculate this same concentration product at any given condition, which is not necessarily your equilibrium condition, then in that case, if ionic product, so we will call this thing as ionic product. So, if you calculate your ionic product at any arbitrary situation and you see that its value is greater than the KSP value, okay, then in that case the precipitation will occur because your solubility or your salt has already been dissolved in water to a large amount. Got it? And further dissolution is not possible. Therefore, you will not see precipitation here. Next, common ion and its effect on equilibrium. So, this is a very important topic which is related to this common ion effect. Now, first of all, what is common ion effect? So, it states that whenever you are taking a weak electrolyte and you are adding a strong electrolyte which has a same ion as your weak electrolyte, in that case, your dissociation will be suppressed for the weak electrolyte. For example, if you are taking ammonium hydroxide, so ammonium hydroxide is a weak base. If you add it to the solution, it will form NH4 plus and OH minus. Now, this is a weak electrolyte, and if you are adding that same NH4 plus through a different electrolyte which is strong in nature. Suppose you take NH4Cl. So NH4Cl is a salt of ammonium hydroxide and hydrochloric acid. Therefore, it will be completely dissociated into the solution, and the NH4 plus ion will be furnished into the solution. As a result of that, the product's concentration will increase. Now, according to the Le-Chatelier principle, this reaction will go back into the previous direction or in the reverse direction, and hence the dissolution of your NH4OH will be suppressed. Is it clear to you? So did you get what is common ion effect? So basically, when you are adding the same ion which is already present in a weak electrolyte through a strong electrolyte, then in that case you will see that there is a suppression of this dissolution, and as a result of this common ion effect, less amount of NH4 plus ion is released from NH4OH. Moving on to the next part. So we have seen the buffer solution, then we have seen your KSP. Now we are moving on to the buffer solution. So first of all, what is buffer solution? So it is something which maintains the pH constant and it reverses its acidic or basic nature if you are adding a small amount of acid or base in a buffer solution. And this nature of your buffer solution to resist the pH change is known as buffer action. Okay, very simple. So for example, you can take your daily life example. In your stomach, you have a buffer solution which is present there. Okay, and it also helps in controlling the pH of your stomach. Similarly, you have a buffer solution in your blood vessel also, which is your application of your buffer solution. Okay, so we have various examples of buffer solution in your human body also. Got it? And what does it do? It resists the pH change by doing something which is known as buffer action. Now we can say that what are the characteristics of buffer solution? This buffer solution has a definite pH value, and this pH value is not changed when you are adding a strong acid in a acidic buffer or a strong base in a basic buffer. Now the question is that how do you calculate this pH value? That what is the particular value of this given buffer solution? So for that we have this Henderson-Hasselbalch equation. So anyone who has a doubt till this point? So we have seen this salt hydrolysis which is used for pH calculation. Then we have seen the sparingly soluble salt, and now we are moving on to the buffer solution. If you have a doubt here, you can just ask it in the comment section. So what is a buffer? So buffer is a solution which resists the pH change if you are adding a small amount of acid or a base in a buffer solution. And you have various application of your buffer solution in your body as well. For example, in your stomach, you have a buffer solution that resists the change of pH in your stomach. Similarly, you have a buffer solution which is present in your blood that resists the change of pH change in your bloods. Okay, so this is a very important point regarding the buffer solution, and you will see questions from this buffer solution in your exams as well. Okay, so you must know how to calculate the pH in that case. Now next, the question is that how do you design a buffer? How do you make a buffer solution? So to understand that, you must know what are the types of buffer solution that are possible. So first is the buffer solution which is having a pH less than 7. So this is an example of acidic buffer. Whenever you take a buffer solution which is containing a strong salt, okay, I would say a strong electrolyte such as your acetic acid and sodium hydroxide salt, then in that case, if you see that there is no complete neutralization, okay, so what did I say? So we are taking a solution which has a salt and its weak acid like sodium acetate and acetic acid. then in that case, your pH will be less than 7. And how do you calculate the pH in that case? For example, we are taking this thing which is your acetic acid and your sodium acetate. So this is an example of acidic buffer. We can also take HCN and NaCN, which is again an example of acidic buffer. So in this case, the pH will be less than 7 and it will be known as acidic buffer. How do you calculate the pH in acidic buffer? So pH is equals to pKa plus log salt by acid, where what is pKa? So pKa is your dissociation constant minus with the negative logarithm for the weak acid that you are taking. Suppose if you take the example of this buffer, so the pKa value will be taken for this acetic acid. Similarly, in the second example, the pKa value will be taken for the HCl. Now, what is the next part? The next part is your basic buffer. So of course, your basic buffer will be basic in nature and it will have a pH more than 7. Now, what can be the example of basic buffer? In your basic buffer, we will have a weak base and a salt of that same. For example, if you take NH4OH and you take the salt of that same NH4, which is NH4Cl. Got it? Now, this will act as a buffer because here we are having a weak base and its salt. Similarly, we can take the example of your C6H5NH2 and C6H5NH3 plus Cl. So here your C6H5NH2 is acting as a base, which is an aniline, right? You know it very well. So this is an example of your aromatic compound which is having a basic nature, and if you react it with HCl, it will give the salt. So if your solution mixture has both the salt and its conjugate base, then this can act as a basic buffer. How do you calculate the basic buffer pH? So for that, first you have to calculate the pOH. It's very simple. So in case of basic buffer, you use the formula for calculation of pOH as pKb plus log salt by base. Now this formula is similar to the previous one, only some terms are changed here accordingly. Since this is a basic buffer, you will calculate pOH rather than pH. So you replace this with pOH. Then rather than writing pKa, since we are taking a weak base, so weak base will have pKb. Similarly, salt will be remain same in both of them, and in place of acid we have the base concentration. So what is the salt's concentration? Of course, we are taking two things here. One is the salt and one is the base. So in the above part, we will put the salt's concentration, and in the denominator we will take the base's concentration. And here we will take the pKb of the weak base. Okay, so here these are the two examples of buffer solution that can exist. Now, next is calculating buffer capacity. So this is a simple measure to see that how much resistance your buffer solution is to change in pH if you are adding some acid or base. If you define it quantitatively, it is defined as the number of moles of acid or bases which can be added to 1 liter of buffer solution to change the pH by unity. Now let me write it mathematically. So buffer capacity will be equals to number of moles of acid or base which you are adding to the solution, buffer solution, to per liter of that buffer solution divided by the change in pH you are observing upon that addition. So suppose you are adding an acid or a base to a given solution. So first of all, you should know that how much you are adding, means you should know the concentration. Then of course the pH will be restrained or it will be resisted. pH change will be resisted by your buffer solution, but still if you keep on adding, there will be a small change in the pH. So you have to write that pH change in the below. And this whole thing defines that how much your buffer solution is resistance towards the pH change upon addition of any acid and base, and you call this as buffer capacity. Now this formula is not that much important, but you can use it to compare two buffer solution that which one is a better buffer. Now, when is the buffer capacity maximum? So this is very important and this is there in your PYQs as well. What does it say? If you go back to your previous formula of your buffer solution pH calculation, so the pH calculation for acidic buffer is given as pH is equals to pKa plus log salt concentration by acid concentration. Now suppose you keep the salt's concentration and acid concentration same. In that case, your pH will be equals to pKa. Why? Because if denominator and numerator are same, that means it will be equals to unity and log 1 value is 0. So your formula for pH will become pH will be equals to pK if the concentration of salt and acid both are same. Similarly, if you are doing it for the basic buffer, then in that case your pH will be equals to pKb. Now remember, greater is this value of buffer capacity, better is your buffer solution, means it has a higher capacity to resist the pH value change upon addition of an acid or base. I hope this is clear to you. So this is all about the theory part. Next we'll move on to question. So if you have a doubt regarding this theory part, you can just ask it here in the comment section. Okay, just wait for a while. Let me switch on to the questions. So here is your first question. You have to say that how many liters of water should be added for 1 liter of an aqueous solution of HCl so that a pH of 1 can be created in a solution to make it pH of 2. Okay. So you have to start with a pH of 2 and you have to make it with a pH of 1. Got it? So you know the initial concentration, you know the final concentration. Similarly, you know the initial volume which is 1 liter, but you have to calculate the final volume. So here you can use your quick formula which is M1V1 is equals to M2V2 to directly calculate the final volume. But here you have to calculate the change in volume. So you have to subtract the final volume with the initial volume, then and then only you will get your answer. So again I am repeating it. What you have to do? You have to move from a pH of 1 to a pH of 2, and you have to do it for 1 liter of an aqueous solution of HCl. Then you have to say that which one will have, what is the volume change that you should do or you should apply to make it of pH 2. Okay. So basically you have to make your solution less acidic. What formula you have to apply? M1V1 is equals to M2V2. So initial molarity can be calculated from pH 1 and pH 2. It's very simple. Okay. Then you can put it in the M1 and M2 part. Similarly, the initial volume is 1 liter and you have to calculate the final volume. Then you have to calculate the change in volume, which is simply final minus initial. So just try it by yourself and tell me the answer in the comment section. So it's a very easy question to do. If you are solving it, please write it in the comment section. What will be the answer for this question? I will give you some time. So what did I say? You have to use the formula M1V1 is equals to M2V2 and you have to simply calculate the final volume. Then you subtract the final from initial and then you can get your change in your volume. Got it? And how do you calculate the initial molarity and the final molarity? So you have your pH here. Got it? So from there you can easily calculate the initial and final molarity. If you just solve it, please comment it here in the comment section. What will be the answer for this question? Okay. So let me give you the correct answer for those who have solved it. The correct answer will be D, which is 9 liter. So, any one of you who got this answer, 9 liter as your answer? Okay. So let us move on to the solution. First of all, you are given with a pH of 1. That means your H plus concentration will be 10 to the power minus 1. Why? Because pH is equals to minus log H plus. If you remove log from there, what you have to do simply is you take the negative sign here and you put it to the power of 10. So that is the simple way you can calculate your H plus concentration from the given pH. Again, I am repeating it. How do you calculate the H plus concentration from pH? So the pH value you are given, just take a negative of that and put it into the power of 10, and that will give you your H plus concentration. Now 10 to the power minus 1 means 1 by 10, and 1 by 10 can be written as 0.1 molar. Now you can similarly apply this same logic to the pH of 2. There, how you will calculate the H plus concentration? You will again take that 2 value, put a negative sign against it, and put it to the power of 10. So 10 to the power minus 2, which is 0.01 molar. So in this way, you can calculate the initial and final H plus concentration. Now, as I said, for the calculation of your final volume, you have to use the formula M1V1 is equals to M2V2. You put the values here. So in initial condition, you have 0.1 molar concentration of H plus and the volume is 1 liter. So it will be 0.1 into 1. Then you know the final molarity into which you have to convert your solution. So it will be 0.01. But you are unaware about this V2, which is the final volume. Okay, means how much water should be added to get your final solution as a pH of 2. If you just solve this simple equation of one variable, you will get it as V2 of 10 liter. Now the question is that you have to calculate the volume change but not the final volume. So this is the part where you can do mistake. Okay. So how you will calculate it? So initial volume is 1 liter, final volume is 10 liter. Therefore, the change in volume will be 10 minus 1, which is 9 liter. So this is your correct answer. I hope this is clear to all of you. Again, I am repeating it. So first we know that what is the initial pH? It is 1. So you convert that initial pH into H plus concentration by taking the negative of that pH and putting it to the power of 10. So that will give you 0.1 molar. Similarly, you can calculate the final pH, which is 2. Sorry, you can use the final pH to calculate the H plus concentration in the final solution. It will be 10 to the power minus 2, which is 0.01. Now, for the dilution of HCl, we know that initially M1V1 is equals to final M1V1, M2V2. Now you put the values here. So 0.1 into 1 is equals to 0.01 into V2. Calculate this, you will get it as 10 liter. Finally, you can calculate the volume change, which is final volume 10 liter minus the initial volume, which is 1 liter. Because you are adding your water into the same solution. So this will be the initial volume of your given solution. So 10 minus 1 will be 9 liter. Next question. The pH of a 0.1 molar solution of acid HQ is 3. So you have to calculate the acid dissociation constant. Okay. Now it's very simple. We know the formula to calculate your alpha. So you have to use that same formula to calculate the Ka. Now for that, you should know that what is the relation between your pH and alpha. Okay. So just try it by yourself. First, what you do is you calculate the alpha value and then you use that alpha value to calculate your Ka. If you are getting the answer, just please write it in the comment section. So first use this pH value to calculate the alpha. So let me give you a hint here. So basically, if you know that pH is 3, that means H plus concentration is 10 to the power minus 3. Now, H plus concentration is equals to C alpha, where C is the concentration and alpha is your dissociation constant. Now, alpha is equals to H plus concentration by C. So from that you can get your alpha. Now, alpha is also equals to root under Ka by C. Got it? So, K will be equals to C alpha square. So, just put the value of alpha calculated from the H plus concentration. You will get your K. Got it? So, H plus concentration is equals to C alpha and alpha is equals to root under K by C. So, these two equations can be used to calculate the answer of the given question. Now, how do you calculate the H plus concentration? In the previous question, as I said, simply take the power to 10, which is your pH with the negative sign. So 10 to the power minus 3. If you have solved it, please comment it here. So how do we solve it? Anyone who is getting the answer? So first try to calculate your alpha. So what will be the answer? Can you just comment it here? A, B, C or D? Okay. Varsha Khare is getting answer as C. Anyone else? Very good, Varsha. Okay, so Suman is telling it as B. So let us see how can we solve it. The correct answer is C, which is 1 into 10 to the power minus 5. Now, as I said earlier, if pH is 3, that means your H plus concentration will be 10 to the power minus 3. And H plus concentration is equals to alpha C. Got it? So I said it earlier. Now, next, you can from here you can calculate your alpha, which will be 10 to the power minus 3 by C. Now, concentration is already given here. It is 0.1. If you put the value here, you will get it as 0.01. So this is your alpha value. Next, we know that from your Oswald dilution law, Ka is equals to alpha square C. So, if you put the value of alpha here, which is 0.01, and it will be square times multiplied by the concentration, which is already given as 0.1, you will get your K value as 1 into 10 to the power minus 5. So, this is your correct answer for the given question. I hope this is clear to all of you. It's a very simple one. Now, moving on to the next question. No problem, Sumant. If you have done it in the same way, then you have solved the question almost. Okay, so calculation problem can be solved with practice. So, next question. You have to say that an acid ionizes as Ha, which is your Ha is your acid. So, it is dissociating as H plus and A minus. Now, the pH of 1.0 molar solution is 5. Its dissociation constant would be. You have to calculate the K value here. So I have created a poll. We have created a poll in here. You can just see that you can just vote it here for the correct answer. So what are we given with? We are given with the pH value of a solution whose concentration is 1.0 molar. Now you have to use this value to calculate the acid dissociation constant. So what will be the answer here? Again, you can use your previous formula to calculate this one. Any one of you who got the answer? Just comment it here. What you have to do is you have to use the pH and your concentration to calculate the dissociation constant. Okay. So the correct answer will be 1 into 10 to the power minus 10, which is option number A. How you will solve it? As I said earlier, it's very simple. HA will dissociate as H plus and A minus. So if 1 is the initial concentration and your H plus concentration is 10 to the power minus 5. It is given here. pH is 5. So H plus concentration will be 10 to the power minus 5. Therefore, we can say that A minus concentration is equals to H plus concentration. Next, what will be K? K will be 10 to the power minus 5 into 10 to the power minus 5 by 1 minus 10 to the power minus 5. Okay. Just put this value here. We know that 1 is greater than 10 to the power minus 5. So we can neglect this thing because this value is very much less than 1. So your final answer will be 1 into 10 to the power minus 5. So you can solve it in this way also, or you can use the previous formulas also. You will get the same answer in both the situations. So what is the other method that you can use? So you have your pH value as 5. So from there you can get your alpha. Okay, so alpha is simply what? Given H plus concentration by C. Okay, so that will be your alpha. Now use that alpha value to calculate the K. So K is C alpha square. Got it? Moving on to the next question. What will be the degree of ionization of 0.05 molar acetic acid if pKa is given as 4.74? So how you will solve it? You have to calculate the alpha value here. Okay, so you are given with the pKa value. First, you should know that how to convert your pKa into your Ka. It's very simple. You will take the negative logarithm of 4.74 and that will give you your pKa value. So just solve it, and I have created a poll here. You can just vote it there for your correct answer. So you have 4 options given here. You have to calculate the alpha value. So there is a direct relation. K is equals to C alpha square. So from pK value, you can calculate the K value and just put it in the formula of C alpha square to calculate your alpha. Just try to solve it by yourself and poll it here. Which option will be correct? A, B, C or D? So I am seeing one vote only. Please vote it here if you are getting a correct answer. You can use your calculator for the time being to calculate the value of K, because it will be given in the exams. Okay, you don't have to worry. You don't have to carry your log table there. It will be given in your exam, your specific value of log and all. You don't have to worry in that case. Here you can use your calculator to calculate the specific value. So what will be the correct answer for this? Please comment your answer here. Please vote it down. What will be the correct answer for this question? Again, as I said earlier, you have to use the formula of K is equals to C alpha square or alpha is equals to root K by C to calculate this value. Okay, you can use your calculator to calculate the value of K from the given pK. Anyone who is getting the answer? Remember, you have to convert your alpha into percentage form. Okay, and for that you have to multiply it by 100. Then and then only you will get it in the percentage form, because the answer is given in the options are given in the percentage form. So please multiply it with 100. Okay, so I'm moving on to the solution. The correct answer will be 1.9%, which is option number B. Now, how we'll solve it? As I said earlier, you will use this ICE table and put it here, okay? In the ICE table, the given concentrations. So, initially it was C, now it is 0 and 0. If you just see it after the dissociation, it will be C into 1 minus alpha, C alpha and C alpha. Next, we can say that pKa is equals to minus log K. Therefore, K will be 10 to the power minus 4.74. If you calculate it here in the calculator, you will get this 10 to the power minus 4.74 as 1.82 into 10 to the power minus 5. Next, we know that K is equals to C alpha square from from your Oswald dilutions law, or alpha is equals to root under Ka by C. You put this alpha value here and concentration is already given as 0.05. Therefore, 1.82 into 10 to the power minus 5 by 0.05 and root under, and if you calculate this you will get it as 0.019. Okay, but remember you have to convert this thing into percentage, and for that you have to multiply this given value with 100. Okay, so rather than giving the fraction you have to give the percentage. And how do you convert your fraction into percentage? It's very simple. You multiply this whole thing by 100. Moving on to the next question. HX is a weak acid whose K is given as 10 to the power minus 5. Okay. Next, it is forming a salt which is having a concentration of 0.1 molar on reacting with caustic soda. Remember, this is the case of complete neutralization because you have to calculate the degree of hydrolysis. Okay, hydrolysis is only possible in the case of salt. Then you have to calculate the degree of hydrolysis. And here, which kind of salt we are taking? We are taking a salt of a weak acid and a strong base. Remember, what was the formula to calculate the KH? How do you calculate the KH? We have already seen its formula in the theory part. So we have created a poll in the comment section. You can just calculate your answer and give it here in the comment section. It's very simple. You have to directly use the formula. It is totally formula based, and just calculate it there and write it down. So I am seeing only 2 votes here. I would expect more votes in the comment section. So please try to solve it. It's a very easy question. You have to calculate the degree of hydrolysis. Okay, I have already given you the formula. It is simply root under KH by C. Okay, and what is KH? KH is KW by K. So first you can calculate KH and use that KH to calculate your H, which is degree of hydrolysis. How you will solve it? Please solve it here and comment your answer in the poll. It's a very simple formula. Just try to remember the formulas and you will only remember it and you will solve numericals on it. So there are three formulas, right? So first is of a weak acid and a strong base, which is H is equals to root under KH by C or root under KW by K into C. For strong acid and weak base, the H is root under Kw by Kb into C. And the third case is of weak acid and weak base. For that case, you have H, which is your hydrolysis constant, is equals to root under Kw by Ka into Kb. So let us move on to the correct answer. So the correct answer will be A, which is 0.01%. Okay. Suppose this is your salt hydrolysis where your salt is reacting with water. So simply you can call it as salt hydrolysis. Okay. Now your HX is a weak acid and the hydrolysis constant for NaX can be given as KH is equals to Kw by K. Okay. So 1 into 10 to the power minus 14 by 10 to the power minus 5. Now if you calculate this, you will get it as 1 into 10 to the power minus 9. Next, as I said earlier, how do you calculate the H? So it is root under KH by C, right? So H can be calculated from here. So you put the values of KH, which is calculated 1 into 10 to the power minus 9 and concentration is 0.1 molar. It is already given in the question. You put it here, you will get your H as 1 into 10 to the power minus 4. But your work is not over yet. You have to convert it into percentage. So for that, multiply it with 100 and your answer will be 0.01%. So this was all for chemistry class today. In few minutes, our maths faculty will join you. If you have a doubt, you can just post it here in the comment section. Anyone who has a doubt? Or still, if you have a doubt after the class, you can just visit our website. From there, you can log on to our doubt clearing session or you can post your specific questions on forum as well. Thank you for joining the session. I hope you enjoyed it.
Hello students, welcome to 40 days lecture series course. So in today's lecture, we will discuss limit, continuity and differentiability. Okay. So as you know, first we will discuss theory part. After that, we will solve some practice questions on this chapter. Okay. This is our disclaimer. So first we will discuss trend analysis. Here we will analyze weightage of this chapter according to last 7 years. Okay. So the weightage of the chapter continuity and differentiability is 6.80 percentage, and this is high weightage chapter. Okay, so you should study this well. And now we will discuss yearly question distribution. Okay, so here we will see in which year how many numbers of questions asked in JEE main exam. Okay, so here you can see in 2024 two questions asked based one continuity of function and higher order derivative. Okay, and the difficulty level was average. Okay students, and in 2023 two questions asked based one derivative at a point and logarithmic differentiation. Okay, and the difficulty level was easy. So that two questions were very easy question. Okay, and then in 2022 three questions asked based one continuity of a function and continuity of a composite function. Okay, and the difficulty level was average also. And then in 2021 there one question asked and that question based one continuity of a composite function. Okay, and the difficulty level was average. Then in 2020 four question asked based one trigonometric identities and differentiation mean value theorem. Okay, and the difficulty level was average, easy and difficult. Okay, then in 2019 three questions asked based one continuity and differentiability. The difficulty level was average and easy. And then in 2018 one question asked based one differentiability. Okay, and the difficulty level was difficult. So this chapter is very high weightage chapter, and the difficulty level of this question of this chapter average to difficult. Okay, now we will see which topic we will cover in this lecture. Okay, so first we will discuss methods to evaluate limits. So there are some methods to evaluate limits. Okay, and we have already studied about limit in our previous lecture. Okay, so now we will see some methods to evaluate limits. So how to evaluate limits, there are some methods that we will learn. After that we will discuss continuity. There we will see what is continuous function and what is discontinuous function. Okay, and there we will see when a function is continuous at some point x equals a and when a function is continuous in an interval. Okay, there we will learn. After that we will discuss some results one continuous function. Okay, so there are some important results one continuous function that will help you to solve any question based on continuity. Okay, so that we will learn very wellly. And after that we will discuss differentiability. There we will learn what is differentiable function. Okay, how to check differentiability. Okay, when a function is not differentiable, that we will discuss. Okay, and there we will also discuss two types of this differentiability, like derivative, like left hand derivative and right hand derivative. Okay, so by checking left hand derivative and right hand derivative exist and equal, we can say the function is differentiable. Okay, that we will learn in this lecture. And then we will see differentiability of a function at a point. So there we will see when a function is differentiable at a point. Okay. And lastly, in theory part, we will discuss results one differentiability. Okay. And after finishing theory part of this chapter, we will practice some questions. One, continuity and differentiability. Okay. So are you ready to start? I hope you were ready and you were with your notebooks and pens. So let's get started. First, we will talk about methods to evaluate limits. Okay, as I told you, there are some methods to evaluate limits, and if you know some methods to evaluate limits, then easily you can evaluate limits of any function. Okay, of any expression. Clear? So now we are going to learn some methods to evaluate limits. So let's see. So first you have to find limit as x tends to a of f of x, and we have to, for finding this, we first substitute x equals a in the function. Okay, so if we substitute x equals a in the function f of x, then you will get f of a. So now you have to check, is this value f of a finite or not finite? Okay, so if f of a is finite, then limit as x tends to a of f of x, this is equal to simply f of a. So when we say limit as x tends to a of f of x equals a f of a, when f of a is finite by substituting x equals a into the function f of x. Okay, so if f of a is finite, then you can say limit as x tends to a of f of x equals f of a. So now find limit as x tends to 0 of x squared plus 1. So everyone find it. What is the limit of x tends to 0 of x squared plus 1? Simply here you can substitute x equals 0 in the function f of x equals x squared plus 1. Okay, and then you will get the value of f of 0. This is equal to 1. So limit as x tends to 0 of x squared plus 1, this is equal to simply 1. Okay, similarly you can find limit as x tends to 1 of x cube plus 2x square plus 1. Okay, so if you have any polynomial function like this, then easily you can substitute x equals a in the function and you can evaluate the limit. Okay, understand? Now if f of a leads to one of the following form, like 0 by 0 form, or infinity by infinity form, or infinity minus infinity form, or 0 times infinity form, or 1 to the power infinity form, or 0 to the power infinity form, and infinity to the power 0. So what we say, these form are called as indeterminate forms. Okay, so 0 by 0, infinity by infinity, infinity minus infinity, 0 times infinity, 1 to the power infinity, 0 to the power infinity, and infinity to the power 0. These forms are called indeterminate forms. So now if your value at x equals a in the function f of x, f of a leads one of the following form, then limit as x tends to a of f of x can be evaluated by using the following methods. So for that you have some methods, okay, that we will learn now. So first method is factorization method. So you all can do factorization of any polynomial function. Okay, so if your function, okay, if your expression take the form 0 by 0, suppose your function the expression you have x squared minus 1 divided by x minus 1. Okay, and you have to find limit as x tends to 1. So what will be the limit of x tends to limit of x squared minus 1 by x minus 1 as x tends to 1? So for finding this limit, you have to use factorization method. Okay, for this you have to factorize x square minus 1. So you can factorize x square minus 1 as x plus 1 times x minus 1. Okay, and then your expression x square minus 1 by x minus 1 can be simplified in the simplest form as x square x minus 1 times x plus 1 divided by x minus 1. Here x minus 1 will cancel to each other and you will get the simplest form x plus 1. Okay, so the expression x square minus 1 upon x minus 1, it becomes x plus 1 simply. Okay, now you can find limit as x tends to 1 easily. Okay, and limit as x tends to 1 of x plus 1, this is equal to 2. So if you have the expression take the form 0 by 0, then you can use factorization method to solve the limit. Clear? Understand? I hope you understand. Now, if your expression take the form 0 by 0 or infinity by infinity, okay, and if your expression either the numerator or the denominator or both involve square roots, okay, that case on substituting the value of x, the expression take the form 0 by 0 or infinity by infinity. Okay, so if your expression like this, then you can use rationalization method. Okay, so you can do rationalization of any fraction type expression. Okay, so if you have 1 by root 2 plus root 3, so you can rationalize it by multiplying and dividing by root 2 minus root 3. Okay, and then you can simplify it and you will get the simplest form. Okay, so like this, if you have the expression either the numerator or the denominator or both involve square roots, and one substituting the value of x, the expression take the form 0 by 0 or infinity by infinity. Okay, then you have to use rationalization method to evaluate the limit. Okay, so suppose you have the function f of x equals x minus 1 divided by root x minus 1. So how to evaluate limit as x tends to 1 of x minus 1 divided by root x minus 1. So here you can see here the expression x minus 1 divided by root x minus 1 involve square root of x in the denominator. Okay, so first of all you have to rationalize this expression by multiplying and dividing by root x plus 1. Okay, so if you multiplying by root x plus 1 in this expression, then what you will get? Then the expression will become x minus 1 times root x plus 1 divided by root x minus 1 times root x plus 1. And you will know the formula root a minus b times root a plus b. This is simply equals a minus b squared. Okay, so here you can see root x minus 1 times root x plus 1. This is simply x minus 1. Okay, and in numerator you have x minus 1. So in numerator you have x minus 1 times root x plus 1, and in denominator you have x minus 1. So now you can cancel x minus 1 in numerator and denominator. Okay, and the expression can be simplified in the form root x plus 1. Now you can find limit as x tends to 1. So limit as x tends to 1 of root x plus 1, this is equal to 2. Okay, so this is how you can evaluate a limit of the expression which involve square roots, and on substituting the value of x, the expression take the form 0 by 0 or infinity by infinity. Clear? Understand? I hope you will understand. Okay, now move to the next. Now here note this fine. To evaluate x tends to infinity type limits, for that if we have to evaluate x tends to infinity, okay, limit x tends to infinity, suppose you have to evaluate limit as x tends to infinity of f of x by g of x. Okay, so if we have to evaluate limit as x tends to infinity, then you first write the given expression in the form n by d. Okay, and then divide both n and d by highest power of x occurring in both n and d to get a meaningful form. Okay, suppose you have limit as x tends to infinity of x square plus x plus 1 divided by x cube plus x square plus 1. Okay, so find the limit as x tends to infinity. Everyone do it. So what is the limit as x tends to infinity of x square plus x plus 1 divided by x cube plus x square plus 1. So here first you write this expression in the form n by d. Okay, and now here you have to divide both n and d by the highest power of x. Here you can see in the given expression x square plus x plus 1, here the highest power is 2, okay, and the in denominator you have the expression x cube plus x square plus 1, here the highest power is 3, okay. So you have to here common you have to divide both n and d by the highest power of x here, and then you have to tend x to infinity, okay, and you will get the answer. So I hope you understand. So here we have studied some methods to evaluate limits, okay. So when you have f of a is finite, then there is no confusion, just you have to substitute x equals a in the function, okay. But if your value of f of a leads one of the following form, 0 by 0 or infinity by infinity or infinity minus infinity or 0 times infinity or 1 to the power infinity or 0 to the power infinity and infinity to the power 0, okay, one of these indeterminate forms, then for that you can use the following methods like factorization method, rationalization method, okay, clear, understand. So now moving to the next, now we will talk about another method to evaluate limits, okay. So another useful and very crucial method is L'Hopital rule, okay, very important. So when you have the indeterminate form 0 by 0 or infinity by infinity, okay, or infinite 0 to the power 0 times infinity, that case you can use L'Hopital rule, okay. So here you have the function f of x and g of x, be two functions of x such that limit as x tends to a of f of x, this is equal to limit as x tends to a of g of x equals 0, okay. So you have given here two functions f of x and g of x, and here limit as x tends to a of f of x, this is equal to limit as x tends to a of g of x is equal to 0, okay, both limit is equal to 0. And here the second thing we have, both are continuous at x equals a, okay. So we will study about continuity in our later section, okay. So here just note here the function f of x and g of x both are continuous at point x equals a, and then third here we have both are differentiable at x equals a. We will also study about differentiability at point x equals a of any function, okay. So just here note f of x and g of x both are continuous at x equals a and both are differentiable at x equals a. And then if f prime of x and g prime of x are continuous at the point x equals a, then you can easily find the limit as x tends to a of f of x by g of x. This is simply equal to limit as x tends to a of f dash of x by g dash of x, okay. So if we have the function f of x and g of x, if your limit of both function as x tends to a is 0 and both are continuous at x equals a and both are differentiable at x equals a, and f prime x and g prime of x both are continuous at the point x equals a, then limit as x tends to a of f of x by g of x, this is simply equal to limit as x tends to a of f prime of x by g prime of x. Here note this point, you should be provided that g of a is not 0, okay. So if we take g of a is 0, then this is not defined, okay. So g of a is here not 0, and this rule is also applicable if limit as x tends to a of f of x is equal to infinity and limit as x tends to infinity x tends to a of g of x is equal to infinity, okay. Here we have seen here the L'Hopital rule for limit as x tends to a of f of x is equal to limit as x tends to a of g of x is equal to 0, okay. But if your limit as x tends to a of f of x is equal to infinity and limit as x tends to a of g of x is equal to infinity, that case you can also apply the L'Hopital rule, okay. So if now f prime of x and g prime of x satisfy all the conditions embedded in L'Hopital rule, then we can repeat the application of this rule again and again, okay. So if f prime of x and g prime x satisfy here all the condition, that means limit as x tends to a of f prime of x is equal to limit as x tends to a of g prime of x is 0 or infinity. Okay, and f prime of x and g prime of x both are continuous at x equals a, and f prime of x and g prime of x both are differentiable at x equals a, and f prime of x and f double prime of x and g double prime of x are continuous at x equals a, then the limit of x tends to a of f prime of x by g prime of x, this is equal to limit as x tends to a of f double prime of x divided by g double prime of x. Okay, again, if your function f double prime of x and g double prime of x satisfy all the condition embedded in L'Hopital rule, then we can repeat the application of this rule for f double prime of x divided by g double prime of x. Okay, so we can repeat this rule again and again if the then derivative satisfy all the conditions embedded on L'Hopital rule. Clear? Understand? So now I am giving you an example. So here in this example you have to evaluate limit as x tends to 1 of x square minus 1 divided by x minus 1. So we've already found its limit by using factorization method, but now by using L'Hopital rule, find the limit. Everyone find what is the limit of limit as x tends to 1 of x square minus 1 divided by x minus 1 by using L'Hopital. Everyone give an answer in chat section. What is the limit as x tends to 1 of x square minus 1 divided by x minus 1? Write your answer. Everyone write your answer. What is the limit as x tends to 1 of x square minus 1 divided by x minus 1 using L'Hopital rule? Everyone write. Give your answer. Very simple question I asked. What is the limit as x tends to 1 of x square minus 1 divided by x minus 1? Here I am giving you a hint. Here as x equals 1, x square minus 1 this is 0 and x minus 1 this is also 0. Okay, so here we obtain 0 by 0 form. Okay, and you can check all the conditions that embedded in L'Hopital rule. Okay, so now what you have to do, so limit as x tends to 1 of x square minus 1 divided by x minus 1, this is simply equal to limit as x tends to 1 of 2x upon 1. Okay, here derivative of x square minus 1 is 2x and the derivative of x minus 1 is 1. So limit as x tends to 1 of 2x upon x 2x upon 1. Okay, as x tends to 1 it goes to 1. So the answer is 2. Yes, good. The correct answer is here 2. Okay, so by using L'Hopital rule we obtain the limit as x tends to 1 of x square minus 1 divided by x minus 1 is 2. Okay, this was very simple question, but this simple question based on very basic concept. Okay, that is L'Hopital rule. Now move to the next. Now we will see another method to evaluate limits. Sometimes we will have some trigonometric functions or logarithmic functions or exponential function. Okay, or inverse trigonometric functions. For that you should know their expansions. Okay, so here we will discuss some expansions that are useful in evaluating limits. So first see the expansion of log of 1 plus x. So what is the expansion of log of 1 plus x? So here you can see log of 1 plus x, this is equal to x minus x square by 2 plus x cube by 3 minus x to the power 4 by 4 plus x to the power 5 by 5 plus dot dot dot. Okay, so this is the expansion of log of 1 plus x. So you should keep in your mind the expansion of log of 1 plus x. Okay, so by using this expansion you can evaluate the limits involved logarithm. Clear? Then another expansion of log of 1 minus x. So if we have log of 1 minus x, okay, here in place of plus if we have minus, then log of 1 minus x, this is equal to minus x squared by 2 minus x cubed by 3 minus x to the power 4 by 4 minus x to the power 5 by 5 minus dot dot dot. Okay, every term will be negative. But if you have log of 1 plus x, here the sign will be alternate, plus minus and so on. Okay, now see here expansion of exponential function e to the power x. So e to the power x, this is equal to 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus x to the power 4 by 4 factorial and plus dot dot dot. Okay, so this is the expansion of e to the power x. So you should keep in mind this expansion also. Okay, and then see here the expansion of a to the power x. So the expansion of a to the power x, this is equal to 1 plus x times log base ea plus x square by 2 factorial times log base ea whole squared plus dot dot dot. Okay, so you can compare e to the power x and a to the power x expansions. Okay, so in a to the power x expansion you have multiplied by log base ea. Okay, but in expansion of e to the power x there is no logarithm. Okay, why? Because if you use this expansion, okay, for e to the power x, if we put a equals e, then all the logarithm, okay, log base e is 1, so here logarithm will be vanish. Okay, that will be become 1 and you will get this expansion 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial plus x to the 4 by 4 factorial plus dot dot dot. Okay, clear? Then we discuss expansion of sin x function. So you will know about sin x function, you will know domain of sin x function, and you also know range of sin x functions. Okay, this is one of the trigonometric function. So the what is the expansion of sin x function? So sin x, this is equal to x minus x cube by 3 factorial plus x to the 5 by 5 factorial minus x to the power 7 by 7 factorial plus dot dot dot. Okay, so this is the expansion of sin x. So whenever you can't solve any limit involve sin x function, you may use their expansion of sin x. Okay, that will simplify the expression and you will get the answer. Okay, and then see here expansion of cos x. So the expansion of cos x is equal to basically 1 minus x square by 2 factorial plus x to the power 4 by 4 factorial minus x to the power 6 by 6 factorial minus dot dot dot. Okay, so now you can compare the expansion of sin x and cos x. So in sin x function the expansion started from x. Okay, and here you have just odd terms like x minus x cube by 3 factorial plus x to the power 5 by 5 factorial minus x to the power 7 by 7 factorial plus dot dot dot. Okay, but in expansion of cos x it started from 1. Okay, and then the other terms are basically even power of x. So 1 minus x square by 2 factorial plus x to the 4 by 4 factorial minus x to the power 6 by 6 factorial minus dot dot dot. Okay, these are some important expansions, okay, that are useful in evaluating limits. Clear? I hope you will understand and it's clear to all of you. Now moving to the next. Now we will discuss continuity. Okay, so when a function is called continuous function, so if you see graphically, so if your function you have you have the graph of the function. Okay, so if the graph of a function has no break or gap, then the function is continuous. Okay, like the function x square. So you know, well, the graph of the function y equal x square, okay, that is actually parabola. Okay, so graph of y equals x square is basically has no break or no gap. So the y equals x square, this function is continuous function. Clear? And see here the graph of e to the power x function. So you will know the graph of e to the power function x function that passes through the point 0, 1. Okay, and there is no break. So the graph of e to the power x has no break. Okay, so x square, e to the power x, this type of functions are called continuous function. Okay, but if you see the function 1 by x and if you see the function greatest integer function x, okay, this symbol denotes the greatest integer function. So 1 by x, greatest integer function of x, these functions are not continuous function. Why? If you check limit as x tends to 0 of 1 by x, this is not defined. Okay, so at x equals to x is equal to 0, the graph of 1 by x has a break. Okay, so 1 by x is not continuous, so 1 by x is discontinuous function. Okay, and if you see the function graph of the function greatest integer function of x, so you can see at the integer point the graph of greatest integer function of x has break. Okay, so that's why 1 by x and greatest integer function of x are discontinuous function. They are not continuous function. Okay, understand what is continuous function and what is discontinuous function. Okay, so when the graph of a function has no break or gap, then the function is continuous, otherwise the function is discontinuous function. Clear? And now see continuity of a function at a point. So suppose you have a point x equals a, okay, and you have a function f of x, then how to see is this function continuous or not at x equals a. Okay, so now we will discuss continuity of a function at a point. So if you have a function f of x, okay, and a function f of x is said to be continuous at point x equals a of its domain. Okay, note here, of its domain, if and only if it satisfies the following conditions. So now see the conditions. Here the first condition is f of a exists where a lies in the domain of f. Okay, here a should be lie in the domain of f and f of a should be exist. Okay, and the second condition here, limit as x tends to a of f of x exists, that is a left hand limit of f of x at x equals a and right hand limit of f of x at x equals a. Okay, that is limit as x tends to a minus of f of x, this is equal to limit as x tends to a plus of f of x. Okay, that means limit as x tends to a of f of x exists. Clear? And the third here, this condition is, you can write LHL, this is equal to RHL. And the third condition, you have limit as x tends to a of f of x should be equal to f of a. Okay, so limit as x tends to a of f of x, this is equal to f of a, and here f of x is said to be left continuous at point x equals a if limit as x tends to a minus of f of x, this is equal to f of a. Okay, and the function f of x is right continuous at x equals a if limit as x tends to a plus of f of x, this is equal to f of a. Okay, that means if the left hand limit, this is equal to f of a, then the function is said to be left continuous at x equals a. If the limit as x tends to a plus of f of x, that means if the right hand limit, this is equal to f of a, then the function is right continuous at point x equals a. Clear? Now we will discuss continuity of a function in an interval. Suppose you have an interval like open interval a comma b, or you have interval close interval a comma b. Okay, so for that, how can you check continuity of a function? So now we will discuss this. So a function f of x is said to be continuous in open interval a comma b if it is continuous at every point of the interval open interval a comma b. Okay, so there is no point in interval a comma b, for that the function is not continuous. Okay, for every point in the interval the function f of x is continuous, then the function is said to be continuous in interval a comma b. So a function f of x is said to be continuous in closed interval a comma b when we say the function f of x is continuous in a closed interval a comma b. Here the function must be continuous in open interval a comma b. In addition, f of x is continuous at x equals a from right side and continuous at x equals b from left. Okay, that means limit as x tends to a plus of f of x, this is equal to f of a, and limit as x tends to b minus of f of x is equal to f of b. Okay, then the function f of x is continuous in closed interval a comma b. So you understand? Clear? Is it clear to all of you? So here we have studied continuity, definition of continuity. Okay, so here we have seen what is continuous function and what is discontinuous function. Okay, so simply you have to remember, if the graph of a function has no break or gap, then the function is continuous. Okay, this is actually geometrically. Okay, but if we want to show algebraically, then you have to see here three conditions for proving continuity of a function at a point. Okay, so a function f of x is said to be continuous at x equals a point of its domain if and only if it satisfies the following conditions. First condition, f of a exists, here a lies in the domain of f, and here limit as x tends to a of f of x exists, that means LHL equals RHL. And the third condition, limit as x tends to a of f of x, this is equal to f of a, and f of x is said to be left continuous at x equals a if left hand limit is equal to f of a, and this function is said to be right continuous at x equals a if right hand limit of f of x is equal to f of a. Okay, and then we have studied continuity of a function in an interval. So suppose you have interval like open interval a comma b. Okay, then the function f of x is said to be continuous in open interval a comma b if this is continuous at every point of the interval open interval a comma b. Okay, then a function f of x is said to be continuous in closed interval a comma b. This case the function f of x should be continuous in open interval a comma b. Also in addition, the function f of x is continuous at x equals a from right and the continuous at x equals b from left. Clear? Understand? I hope you will understand. Very simple concept. So now moving to the next. Now we will discuss some results one continuous function. So there are some important results one continuous function that will help to solve any question one continuous function. Okay, so see the results one continuous function. So first result, sum, difference, product and quotient of two continuous function are always a continuous function. Suppose you have the function f of x and g of x. Okay, and now the function f of x and g of x both are continuous, then sum of these two functions f of x plus g of x is also continuous, and the product of these two functions f of x and g of x is also continuous. Okay, and f of x by g of x is continuous only if g of a is not 0. Okay, and then see the second result, one continuous function. So every polynomial function is continuous at each point on real line. Okay, so if you have the polynomial like an x to the power n plus an minus 1 x to the power n minus 1 plus an minus 2 x to the power n minus 2 plus dot 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 plus a naught. Okay, here an is not 0, then the polynomial is n degree polynomial. So this type of function is always continuous at each and every point of real line. Clear? And the third result, every rational function. So what is rational function? So if your function f of x is equal to p of x upon q of x, here q of x is not equal to 0 and here p of x and q of x both are polynomial. Okay, then the function f of x equals p of x by q of x is called rational function. So you have to note here every rational function is continuous at each point where its denominator is different from 0. Okay, and then fourth result, one continuous function. So logarithmic function, exponential function, trigonometric functions, inverse circular functions and modulus functions, these functions are continuous in their domain. Okay, suppose you have log base e of x. Okay, so you can check the continuity of this function. Okay, so this is continuous function. If we have e to the power x function or a to the power x function, so this type of functions are continuous function. If you have sin x, cos x, tan x, cot x, sec x, cosec x, okay, so these functions are continuous function. So if you have inverse circular functions, that function are also continuous function. If you have the modulus function mod of x, okay, so you will know the graph of mod of x, the graph of mod of x has no break. Okay, so mod of x is continuous function, okay, at every point of real line. Okay, so logarithmic function, exponential function and trigonometric functions, inverse circular functions and modulus functions are continuous in their domain. Clear? Understand? Now see the fifth result one continuous function. So greatest integer function, you will know about greatest integer function. Okay, what is greatest integer function? The greatest integer function of x is defined as x equal to 0 when 0 less than equal to x less than 1. Okay, and greatest integer function of x is equal to 1 when 1 less than equal to x less than 2. Okay, and greatest integer function of x is equal to 2 when 2 less than equal to x less than 3, and so on, when greatest integer function of x equals n when n less than equal to x less than n plus 1. Okay, so this is how we define greatest integer function. So greatest integer function is discontinuous when x is an integer. So when you take x is an integer, then the greatest integer function is discontinuous, otherwise the greatest integer function is continuous. Okay, now see the sixth result, one continuous function. So if g of x is continuous at point x equals a and f is continuous at g of a, then composition of function f and g. So f composition g is continuous at x equals a. When we say when g of x is continuous at point x equals a and the function f is continuous at point g of a, then f composition g is continuous at x equals a. Clear? Understand? And then see seventh result one continuous function, that is the function f of x is continuous function defined one closed interval a comma b such that f of a and f of b are opposite signs. Okay, when f of a and f of b are opposite signs, when the multiplication of f of a and f of b is less than 0. Okay, so f of a times f of b is less than 0, then they have opposite signs. So f of x is continuous function and it defined one closed interval a comma b such that f of a and f of b both are opposite signs. There is at least one value of x for which f of x vanishes. Okay, so that means there exists one value of x for which f of x is equal to 0. Okay, then the function is continuous. Define one closed interval a comma b. Understand? I hope you will understand. Now we will discuss differentiability. Okay, so what is differentiability and how to check differentiability of a function? So here see the function f of x is differentiable at a point p if and only if there exists a unique tangent at point p. Okay, you will know about tangent. So if the function f of x is differentiable at a point p if and only if there exists a unique tangent at point p. Okay, so this is both side implication. Okay, so if the function is differentiable at point p, then you can say there exists a unique tangent at point p, and otherwise if there exists a unique tangent at point p, then the function f of x is differentiable at point p. Okay, so in other words you can say f of x is differentiable at a point p if and only if the curve does not have p as a corner point. Okay, when the function has no corner points, then the function is differentiable at every point. Okay, but if the function has corner points like holes or sharp edges, then the function is not differentiable. Okay, that is the function is not differentiable at those points where graph of the function has holes or sharp edges. Okay, so now let us consider the function f of x equals mod x. Okay, first take this function f of x is equal to mod x. Is this function differential function? The function f of x is equal to mod of x. The graph of function is like this v, okay, and it passes through the 0, okay, origin. So you can see the graph of y equals mod of x has a sharp edge at point x equals 0. Okay, so we know if the function has holes or sharp edges, the function is not differentiable. Okay, but here the function f of x equals modulus of x has a sharp edge, so the function f of x is equal to mod of x is not differentiable. Clear? So now let us consider the function f of x is equal to mod of x minus 1. So find the not differentiable point of f of x is equal to mod of x minus 1. You can check easily this function is not differentiable at x equals 1. Why? You can check the graph. Okay, you can draw the graph of f of x equals mod of x minus 1, and there you will see at x equals 1 point the function f of x has sharp edge. Okay, and we know if the function has any sharp edge or holes, then the function is not differentiable. Okay, so the function f of x equals mod of x minus 1 is not differentiable. So now we will visualize it by graph. So you can see here the graph of mod of x minus 1. Okay, so this line is for f of x equals minus x plus 1, and this line is for f of x equals x minus 1. You can find here left hand derivative of f of x. Okay, here minus 1, and here right hand derivative of f of x is 1. Both are not equal. Okay, exist but not equal. So at x equals 1 point, this function is not differentiable. Otherwise you can say the function f of x equals mod of x minus 1 has a sharp edge at x equals 1. Okay, this is why the function f of x is equal to mod of x minus 1 is not differentiable. Clear? Understand? I hope you all understand. Very simple concept. Now moving to the next. Now we will see some important definition like a differentiability of a function at a point. Okay, so a function f is said to be differentiable at point x equals c if left hand and right hand derivatives at c exist and are equal. Okay, now we will discuss what is left hand derivative and what is right hand derivative. Okay, and when they exist, and if they exist, then if they are equal, then the function is said to be differentiable function at x equals c point. Okay, so now see here, right hand derivative of f of x at x equals a denoted by a prime of a plus 0 comma a prime or a prime of a plus, this is equal, this is actually limit as h tends to 0 of f of a plus h minus f of a divided by h. Okay, so this is called right hand derivative of f of x at x equals a. So when we check the function is differentiable, that case you have to check first right hand derivative of f of x at x equals a, and then you have to check left hand derivative of f of x at x equals a. So here see, left hand derivative of f of x at x equals a is denoted by a prime of a minus 0 or a prime of a minus, and this is limit as h tends to 0 of f of a minus h minus f of a divided by minus h. Okay, this is left hand derivative of f of x at x equals a. So this is how you can find right hand derivative of any function f of x at x equals a and left hand derivative of f of x at x equals a. Clear? Then thus the function f is said to be differentiable at x equals a if a prime of a plus 0, this is equal to a prime of a minus 0. Okay, that means the function f is said to be differentiable at x equals a if left hand derivative a prime of a plus 0 and right hand derivative a prime of a minus 0 both exist at point x equals a and both are equal. Okay, then the function is differentiable, otherwise the function is not differentiable. Okay, clear? And the value should be finite. Then the common limit is called the derivative of f of x at x equals a, and this denoted by a prime of a. So that is a prime of a is equal to limit as x tends to a of f of x minus f of a divided by x minus a. Okay, this is common limit. Okay, and this is called the derivative of f of x at x equals a, and it is denoted by a prime of a. Clear? Understand? All you understand? Do you have any doubt? So here in this slide we have studied right hand derivative of f of x at x equals a and left hand derivative of f of x at x equals a, and then we see the function f is said to be differentiable at x equals a if a prime of a plus 0, this is equal to a prime of a minus 0 is equal to finite number. Okay, and then here we have seen the common limit is called the derivative of f of x at x equals a, and it denoted by a prime of a, and a prime of a is equal to limit as x tends to a of f of x minus f of a divided by x minus a. Clear? Understand? Now we will see some results 1 differentiability. Okay, so there are some important results 1 differentiability that now we will discuss. Okay, so note here first result 1 differentiability, that is every polynomial, constant and exponential function, every polynomial function, constant function and exponential function. You all know about polynomial function, constant function and exponential function. Okay, so every polynomial, constant and exponential function is differentiable at each x belongs in set of real numbers. Clear? And then see here next result 1 differentiability, that is the logarithmic, trigonometric and inverse trigonometric functions are differentiable in their domain. Okay, that means log base something and trigonometry like sin x, cos x, tan x, cosec x, sec x, these are differential function at their domain, and inverse trigonometric function like sin inverse of x, cos inverse x, tan inverse of x, cot inverse of x. Okay, this type of functions are differentiable in their domain. Now see another result 1 differentiability. Okay, that is if two functions are differentiable, then the sum, difference, product and quotient of two function is differentiable. Clear? And the fourth result, one differentiability, that is every differentiable function is continuous, but converse may or may not be true. Okay, that means every differentiable function is continuous. If the function is differentiable, then the function is continuous. Okay, but if the function is continuous, then it not necessary to be differentiable function. Okay, so every continuous function is not differentiable function, may or may not be differentiable function. Okay, so you can take counter example like f of x equals mod of x. Okay, so f of x equals mod of x is continuous function at every value of x equal x belongs to set of real numbers. Okay, so the function mod of x is differentiable, not differentiable. Okay, why? Because f of x equals mod of x has a sharp edge at x equals 0 point. Okay, so at x equals 0, right hand derivative of mod of x and left hand derivative of mod of x not same. Okay, that's why the function mod of x is not differentiable, but this function is continuous. So here we have seen there exists a function which is continuous but not differentiable. Clear? Understand? Now we will discuss some practice questions, one continuity and differentiability. Okay, so wait a moment. So students, now we will discuss some question, one continuity and differentiability. Now let's look at question number 1 here. So in this question you have to find the value of limit as n tends to infinity of cos of x by 2 times cos of x by 4 times cos of x by 8 times dot 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 cos of x by 2 to the power n. Okay, and you have here 4 options. So you have to choose the correct answer from the given ones. So first of all, try it yourself and give your answer in chat section. Everyone do it. Which option is correct here? Give your answer. Which option? Try it for a couple of minutes and give your answer in chat section. Which option is correct here? Very easy question. You can do it. Solve it in your notebooks and give your answer in chat section. Choose your answer. Which option is correct here? Everyone do it and give your answer in chat section. Which option? Quickly do it and choose your answer here in chat section. Very simple question. I hope you got your answer. So now let's check which option is correct here. Here the correct answer is here option B. Okay. So now let's solve this question step by step. So we know that cos A times cos 2A plus cos 4 times A times dot 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 cos cos 2 to the power n minus 1 times A. This is equal to sin 2 to the power n A divided by 2 to the power n times sin A. Okay, you all know this result. Okay, note this. Here cos A times cos 2A times cos 4A times dot 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 cos 2 to the power n minus 1 times 2 to the power n minus A. Okay, this is equal to sin to the power 2n A divided by 2 to the power n times sin A. Okay, understand? Now here take A equals x by 2 to the power n. Because you have here, you can see x by 2 to the power n. So just take here A equals x by 2 to the power n. Then you can write this limit as n tends to infinity of cos of x by 2 to the power n times cos of x by 2 to the power n minus 1 times dot 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 cos of x by 4 times cos of x by 2 is simply is equal to sin x upon 2 to the power n times sin of x by 2 to the power n. Okay, by using this result we can write this as sin x upon 2 to the power n sin of x by 2 to the power n, and therefore limit as n tends to infinity of cos of x by 2 times cos of x by 4 times dot 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 cos of x by 2 to the power n minus 1 times cos of x by 2 to the power n is equal to limit as n tends to infinity of sin x divided by 2 to the power n times sin of x by 2 to the power n. Clear? Understand? Now we can analyze the limit of right hand side here. As n tends to infinity, you can see x by 2 to the power n tends to 0. Okay, we can now negligible. Okay, we can now neglect sin of x by 2 to the power n can be approximate to x by 2 to the power n. Okay, so use this approximation. Sin y is approximately equal to y as y tends to 0. Clear? Why? Because as n tends to infinity, x by 2 to the power n tends to 0. Now sin of x by 2 to the power n is approximately equal to x by 2 to the power n. Okay, as n tends to infinity of x by 2 to the power n tends to 0. Clear? Thus we have limit as n tends to infinity of sin x upon 2 to the power n times sin of x by 2 to the power n. This is equal to limit as n tends to infinity of sin x divided by 2 to the power n times x by 2 to the power n. Okay, and here you can observe 2 to the power n, 2 to the power n will be cancelled to each other, and then you will get the limit as n tends to infinity of sin x upon x. Okay, and here you are taking limit as n tends to infinity, and you have sin x upon x. Okay, so we can treat here sin x upon x as constant. Okay, and we'll get the limit as n tends to infinity of sin x upon x is sin x upon x. Okay, and this is our final answer. So the value of limit as n tends to infinity of cos of x by 2 times cos of x by 4 times cos of x by 8 times dot 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 cos of x by 2 to the power n is sin x upon x. Clear? Understand? I hope you will understand. So now moving to the next question. So in this question, you have the function f is periodic with period t. Okay, you will know the definition of periodic function. If the function f of x is periodic function with period t, then f of x equals f of x plus t. You will know this. Okay, and here you have f of x is greater than 0 for all x belongs in set of real numbers. Okay, then you have to find limit as n tends to infinity of n times f of x plus t plus twice of f of x plus 2t plus dot 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 n times f of x plus nt divided by f of x plus t plus 4 times f of x plus 4t plus dot 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 plus n square times f of x plus n square t. Okay, so using this periodic function, definition of periodic function, and here f of x is greater than, find the limit of this expression and give your answer. Choose here correct answer from the given 4 options. So which option is correct? Try it on your one first. Everyone do it and choose your answer. Which option is correct? Very simple question. just you have to use here f of x equals f of x plus t. Okay, and you know when f of x equals the function is periodic with period t, then f of x plus t, f of x plus 2t, f of x plus nt all are equal to f of x. Okay, and f of x plus t, f of x plus 4t plus dot dot plus and both f of x plus n squared t all are equal to f of x. Okay, using this hint and find the limit. So everyone give your answer in chat section. Which option is correct here? Very simple question. You can do it very easily. Everyone do it and give your answer. Which option? I hope you got your answer. So now let's check which option is correct here. So the correct answer is here option C. Clear? Now let's solve this question step by step. So clearly f of x plus t is equal to f of x plus 2t is equal to dot dot f of x plus nt cos f of x. Okay, and f of x plus t, f of x plus 4t plus dot 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 and is equal to dot 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 is equal to f of x plus n square t is equal to f of x. Okay, so use this concept and give your answer. So here now you can evaluate the limit. Limit as n tends to infinity of n times f of x plus t plus twice of f of x plus 2t plus dot 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 plus n times f of x plus nt divided by f of x plus t plus 4 times f of x plus 4t plus dot 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 plus n square times f of x plus n square t. This is equal to limit as n tends to infinity of n times f of x times 1 plus 2 plus 3 plus dot dot plus n. Okay, and divided by f of x times 1 squared plus 2 square plus 3 square plus dot dot plus n square. Okay, now just use the sum of first n natural number. So you will know the formula of sum of first n natural number, that is n times n plus 1 by 2. Okay, and you will know the sum of first square of first n natural number. Okay, that is n square 1 squared plus 2 square plus 3 square plus dot plus n square. This is equal to n times n plus 1 times 2n plus 1 by 6. Okay, so use this formula and now evaluate the limit. So this is equal to limit as n tends to infinity of n times n plus 1 by 2 divided by n times n plus 1 times 2n plus 1 by 6. Okay, now simplify this and you will get the simplest form is 3 by 2. So the limit as n tends to infinity of n times f of x plus t plus f of x plus 2 twice of f of x plus 2t plus dot dot plus n times f of x plus nt divided by f of x plus t plus 4 times f of x plus 4t plus dot dot plus n square times f of x plus n square t is equal to 3 by 2. Okay, and this is our final answer. So I hope you will understand how we solve it. Okay, now moving to the next. In this question, you have to evaluate the limit as x tends to 0 of 1 minus cos 2x times 3 plus cos x divided by x times tan 4x. Okay, so evaluate the limit. Okay, and try it by yourself first. Everyone take your time and do it and give your answer. Which option is correct here? Everyone do it. Take your time and do it. Very simple question. Just here you have to use the formula 1 minus cos 2x. This is equal to twice of sine square x. Okay, use this formula and then evaluate the limit and give your answer in chat section. Okay, here choose the correct answer from the given options. So everyone do it. Very simple. You can do it. Very simple question this is. Try it. Very simple question. Try it. Which option? Just here use cos 2x equals 1 minus 2 sin square x formula. Okay, and from there you will get 1 minus cos 2x equals 2 sin square x. Okay, and there simplify, then you have to simplify, and then you will get the limit of this expression. Okay, clear? Understand? So I hope you got your answer. So now let's check the option, which option is correct. Here the correct answer is option C. Okay, so option C is here the correct answer. So let's now solve this question step by step. So here we have to evaluate the limit as x tends to 0 of 1 minus cos 2x times 3 plus cos x divided by x times tan 4x. Okay, so we have to evaluate this limit. So how to evaluate it? So you can write 1 minus cos 2x as 2 sin square x. Okay, and you can arrange tan 4x here, tan 4x by 4x times 4x. Okay, like this, and then this is equal to limit as x tends to 0 of 2 sin square x times 3 plus cos x divided by x times tan 4x by 4x times 4x. Okay, and since you know limit as theta tends to 0 of sin theta by theta is 1, and limit as theta tends to 0 of tan theta by theta equals also 1. Okay, so use this formula and then evaluate the limit, and here you have to separate all the limits. So you can write this limit as x tends to 0 of 2 sin square x by x square times limit as x tends to 0 of 3 plus cos x by 4 times 1 by limit as x tends to 0 of tan 4x upon 4x. Okay, so you know limit as x tends to 0 of sin square x by x square is 1. Okay, and limit as x tends to 0 of tan 4x upon 4x is also 1, and here as x tends to 0 3 plus cos x tends to 3, so you can simply get here the answer is 2 times 4 by 4 times 1 is equal to 2. Okay, here the correct answer is 2. So I hope you will understand this question was very simple question. Okay, just here we do algebraic manipulation, and we get the answer. Here the final answer is 2. Okay, understand? I hope you will understand. Now moving to the next. In this question you have the equation as limit as x tends to 0 of a minus n times nx minus tan x times sin nx by x square, this is equal to 0. Okay, where n is non-zero real number, and then you have to find the value of a. So a is equal to what? Here we have given 4 options. So everyone write your answer in chat section, which option is correct. Everyone do it, try it yourself first and give your answer, which option is correct. Choose your answer in chat section. Everyone do it. Very simple question. You can do it. Okay, just you have to find here the value of a. Do it. Take your time and do it. Use this equation and find the value of a. Quickly do it. Very simple question. It hardly takes 1 minute. Give your answer in chat section. Which option? Which option is correct here? I'm waiting for your answer. Which option is correct here? Are you trying to do it? Try it. And give your answer in chat section. Okay, do it. I hope you got your answer. So now let's check which option is correct. Okay. So the correct answer is option D. So everyone match with your answer. Okay. So now let's solve this question step by step. Since here limit as x tends to 0 of a minus n times n minus tan x upon x times sin nx by x is equal to 0. Okay. So then it implies a minus n times n minus limit as x tends to 0 of tan x upon x times limit as x tends to 0 of sin nx by x is equal to 0. Okay. And since here you can write sin nx by x as sin nx by nx times n. Okay. So here you get limit as x tends to 0 of tan x by x is 1, and since limit as x tends to 0 of sin x upon x is also 1. So using this and evaluate the limit of this expression. So here a minus n times n minus 1 times limit as x tends to 0 of sin nx by nx times n, this is equal to 0. And since limit as x tends to 0 of sin nx by nx is 1, so it implies a minus n times n minus 1 times n, this is equal to 0. Okay. So we got this equation, and now from this equation you will get the value of a. So now let's simplify it. So it implies a minus n times n is equal to 1. Okay. Then it implies a equals n plus 1 by n. So the value of a is equal to n plus 1 by n, and this is our final answer. So I hope you will understand. This was very simple question. Just we use algebraic manipulation. Okay, and we have got our answer, n plus 1 by n. Okay, clear? Understand? Now moving to the next. In this question, we have to find limit as x tends to 0 of sine of pi cos square x upon x square. Okay. So here you have given 4 options. So among these 4 options, which option is correct, that you have to find. So everyone do it and give your answer. Which option is correct here? Everyone do it. Take your time and do it. Everyone. And give your answer in chat section. Everyone do it. Very simple question. Use here cos square x equals 1 minus sin square x. Okay. And then use some trigonometric formula. Okay. And then you can evaluate easily limit as x tends to 0 of sine of pi times cos square x upon x square. Okay. Clear? So give your answer in chat section. Which option is correct? Everyone do it. Very simple question. Easy question. You can do it. Give your answer. Which option? Which option is correct here? Are you trying? Are you trying to do it? Right? Your answer? Which option? Okay, I hope you got your answer. So now let's check which option is correct. The correct answer is option D. Okay, now we will see the solution step by step. Here you have to evaluate limit as x tends to 0 of sine of pi times cos square x divided by x square. Okay, and now you can use cos square x is equal to 1 minus sin square x. Okay, so now you can write this limit as x tends to 0 of sine of pi times 1 minus sin square x divided by x square. Okay, and this is equal to limit as x tends to 0 of sine of pi minus pi sin square x divided by x square. Okay, and you will know sine of pi minus theta is equal to cos that is equal to sin theta. Okay, so since you have sine of pi minus theta equals sine theta. So now limit as x tends to 0 of sine of pi minus sine square x upon x square. Okay, this is. Now you can write this limit as x tends to 0 of sine of pi sine square x upon pi sine square x times pi times sine square x upon x square. And since you have limit as theta tends to 0 of sine theta by theta is 1, so use this trigonometric limit and then you will get the answer pi. Okay, this is our final answer. So I hope you will understand. Now moving to the next. In this question, you have the function f of x as determinant of sin x, cos x, tan x, x cube, x square, x, 2x, 1, 1. Okay, and then you have to find limit as x tends to 0 of f of x by x square. Okay, so you have given here 4 options. So you have to choose the correct option from the given ones. So everyone do it and give your answer. Which option is correct here? Everyone do it. Try it yourself first. Everyone do it and give your answer. Which option is correct? Just you have to evaluate here the determinant. Okay, and then just you have to some calculation and then you will get the limit. Okay, as x is 0 of this expression f of x by x square. So everyone do it. Which option is correct here? Take your time and do it. Everyone give your answer in chat section. Very simple question. Just you have to calculate, you have to do some calculation. Okay, everyone do it and give your answer. I hope you understand how to do it. Okay, and I hope you got your answer. So now let's check which option is correct here. The correct answer is option D. Okay, so everyone match with your answer. Now let's start the solution step by step. So here f of x is equal to x square sin x plus x cube tan x plus 2x square cos x minus 2x cube tan x minus x cube times cos x minus x times sin x. How we obtain? By evaluating the determinant of sin x, cos x, tan x, x cube, x square, x, 2x, 1 and 1. Okay. So if we evaluate the determinant, then you will get the function f of x like this. And then you can simplify this function as f of x is equal to sin x times x square minus x plus cos x times 2x square minus x cube times tan x. Now write the expression f of x upon x square and then evaluate limit as x tends to 0. So limit as x tends to 0 of f of x upon x square. This is equal to limit as x tends to 0 of sin x times x square minus x plus cos x times 2x square minus x cube times tan x divided by x square. Okay. Now substitute the value of x is equal to 0 in numerator and denominator. So if you substitute x equals 0 in numerator and denominator, then you will get the form 0 by 0 form. Okay, so now you can apply L'Hopital rule. So here it is in 0 by 0 form. So by L'Hopital rule, limit as x tends to 0 of cos x times x square minus x plus sin x times 2x minus 1 minus sin x times 2x square minus x cube plus cos x times 4x minus 3x square times tan x minus x cube times x square x divided by 2x. Okay, here we differentiate numerator and denominator and we evaluate limit as x tends to 0. Again you can see this is also 0 by 0 form. So again using L'Hopital rule and differentiate. Okay, again differentiate the numerator and denominator. So if you differentiate, so you do this differentiation of this expression, okay, numerator, and you will put the value of x equals 0, then you will get minus 1 plus 4 plus 0 divided by 2. Okay, I know you can do it, and this implies this is equal to minus 2 plus 4 by 2, this is equal to 2 by 2 equals 1. Okay, so the limit as x is 0 of f of x by x square is equal to 1. Clear? Understand? Do you have any doubt? So if you have any doubt, then you can freely ask now. Do you have any doubt? All thing clear? Everything is clear? Yes or no? Do you have any doubt? I hope you have no doubt. Okay. So everything is clear to all of you. So that's all for today's lecture. So thank you very much for all of you. And I hope this lesson was helpful to all of you. So stay tuned for physics class.
Hello, students. Welcome to today's lecture. In today's lecture, we are going to learn about mechanical properties of matter. and this is theory part 2. Alright, this is our disclaimer. So in today's lecture, we will cover first viscosity, then terminal velocity. After that, we will discuss Stokes law. Then we will discuss streamline and turbulent flow. Then we will learn critical velocity. Alright everyone. Then equation of continuity. This is most important for the exam. Then we will discuss energy of a flowing liquid. After that, Bernoulli's principle. Then velocity of efflux. Efflux means flowing outward. Okay. Then applications based on the Bernoulli's principle. Then surface tension. Then surface energy. Then angle of contact. Then we will discuss about excess pressure over a liquid film. And last, we will see capillary rise or capillarity. So these are the topics which we will cover in today's lecture one by one. Okay everyone? Yes or no? If yes, uh, write in the chat box. So the first concept is viscosity. So what is viscosity? You must have seen that on one side there is a water and other side there is a honey. Okay. So if you are asked which of these is thicker, you will say honey. Yes or no? You must have observed that water flows very easily, whereas honey does not flow as easily. So we can say that the viscosity of honey is greater than that of water. Okay. So look, viscosity is a property of a fluid due to which it opposes the relative motion between its different layers. Instead of looking at the entire fluid as a whole, we will say that the entire fluid is made up layer by layer. So here in this look at figure, here this is the fluid which is made layer by layer. So these are the layers. Okay. You can also understand it this way. There is a fixed surface below. Look at here, this one. And above it, above the fixed surface, uh, layers of fluids. So viscosity is a property of a fluid due to which it opposes the relative motion between its different layers. Therefore, we need to change our perspective. We should not look at the entire fluid as a whole, but rather observe it layer by layer, layer by layer. Okay, everyone? So, understanding that is structured this way. All right. Now, if the surface, this surface is fixed, so in that case, velocity v equal to 0. Yes or no? Bottoms layer. So the force that acts between those layers which opposes their relative motion is called viscous force. And we think of a fluid layer by layer, meaning its layer flow in this manner. Alright, look at here. So when there is a relative motion between two layers, the force that opposes this relative motion is called viscous force, and this property of fluid is called viscosity. and this viscosity is different for every fluid. Some have less, some have more. For example, honey's viscosity is higher compared to water because its layer do not flow like water. Okay, so the viscous force between them is very high. Clear everyone? Yes or no? Please write in the chat box. Mark your attendance. The concept about the viscosity is clear. Yes or no? Anyone? Good Varsa Khare. All right. So if there are two fluid layers having surface area A and viscosity gradient dV upon dr, then the viscous force is given by F equal to minus eta A dV upon dr. And you need to remember this formula, okay, for the examination, where constant eta is called the coefficient of viscosity of the given fluid. All right. So if we talk about these arrows, so we can say here, look at here, the arrow, the movement of particles as we go towards up, so the velocity increases. And here the bottommost layer will remain stationary and its velocity will close to zero. It won't be exactly zero, but it will be very close to zero, whose velocity is zero. Okay, the velocity of the fixed surface is zero. So the layer above, which is fluid layer, its velocity will be lowest. So the velocity of the layer above it will be slightly higher, and the velocity of layer above that will be even higher. And the increasing the size of arrow indicates that velocity of topmost layer is highest. So the if there are two fluid layers having surface area, so this is the formula of gradient, F equal to minus dv minus eta A into dv upon dr. All right. If we talk about the SI unit, so we can say SI unit of coefficient of viscosity is Newton per meter square second or Pascal second, or we can say Poisson law. Next is terminal velocity. Okay, so think about it. What is terminal velocity? Yes, tell me. Anyone? So there is a three figures: body released from rest, uh, forces on body during acceleration, and forces on body at terminal velocity. So which one is the uh, here? Uh, you can say having in motion. So before understanding this, you need to know about the definition of terminal velocity. Terminal velocity, if a small spherical body is dropped in a fluid, then initially it is accelerated under the action of gravity. So when we can say, we explain it simply, think about it, when a small, this one, when a small spherical body is dropped in a fluid, okay, like water or air. The three stages of motion occur. We have a three stages, okay. So let's understand them one by using the diagrams shown in the figure, okay everyone. So the first case, just after release. So here it shows just after release. So only weight, that is mg, acts downward. All right. So drag force equal to 0 because the body has not started moving yet. So we can say the body begins to accelerate downwards due to gravity. And if we talk about the second case, during motion, or we can say acceleration phase. So in this case we can say the body starts moving. The body starts moving vertically downward. So weight is still acts downward, that is mg here, okay, and the drag force, resistance of fluid, acts upward, okay, yes or no. So we can say increases as speed increases. So result will be, we can say net force is equal to mg minus drag force. And if we talk about the third case, at terminal velocity, so eventually as the speed becomes large. So here again the weight of body, spherical body, is vertically downward, mg here, look at here, okay, and acceleration becomes what? So here the drag force is vertically upward, in upward direction. So now net here the drag force equal to mg, drag force equal to mg, okay. So we can say net force equal to 0. So the acceleration becomes 0 and the body now falls with a constant speed called terminal velocity, okay everyone. So these are the three cases. Any doubt here? So however with an increase in speed, the viscous force increases and soon it balances the weight of the body. Now the body moves with a constant velocity called terminal velocity. So to calculate the terminal velocity, the formula is Vt equal to 2 by 9 r square rho minus sigma into g divided by eta. Okay. So the expression, this expression is to calculating the terminal velocity, where r equal to radius of the falling body, rho equal to density of the falling body, and sigma equal to density of fluid. Okay. All right. Clear everyone? Any doubt here? All right. Next is Stokes law. Stokes law states that if a small spherical body, look at here, small spherical body uh, with radius small r is moved at a constant speed, that constant speed is v, and if the object is placed in a fluid uh, and it starts moving with constant speed v, which we call terminal velocity, and the coefficient of viscosity on it is eta, so F equal to 6 pi eta RV. Okay, everyone. So this is the viscous force. Next is streamline and turbulent flow. So now we will talk about streamline and turbulent flow. So the flow of a fluid is called streamlined when each individual element or particle of the fluid follows a particular fixed path. Okay, and in this condition, the velocity that the first particle has at a specific point, all second, third, and subsequent particles cross that point and exactly the same velocity. So there is a no mixing or sudden changes. Look at here. So this is the laminar flow. Okay, the flow of a fluid in well structured way. Okay, there is a no mixing or sudden changes. So laminar flow is a special and very common examples of this type of smooth ordered flow where the fluid follows in parallel layers without disturbing each other. Okay, okay, everyone. If we talk about the turbulent flow, all right. So if we talk about the turbulent flow, it is when the motion of the fluid particles is irregular or disordered. Okay, look at here. So this is the best example of the turbulent flow. Here the flow of fluid is irregular, and they do not follow any specific path or any specific pattern. So we can say this is turbulent flow. Next is critical velocity. For a fluid, the critical velocity is that limiting velocity of the fluid flow up to which the flow is streamlined and beyond which the fluid becomes turbulent. So the value of critical velocity for the flow of liquid of density rho and coefficient of viscosity eta flowing through a horizontal tube of radius r is given by Vc equal to eta into Re divided by rho r. Okay. So here critical velocity is directly proportional to eta and inversely proportional to density, that is rho here, and the radius of the cube. So we can say the higher the density of the fluid, the lower the critical velocity will be, because they are inversely related. Okay, everyone. Similarly, we can say the wider the tube, the lower the value of critical velocity. Okay, this means if the pipe is very wide, then if we compare two cases, one with a larger radius will have a lower critical velocity value, and more viscous the liquid we take, so the higher critical velocity will we get. So the critical velocity here, velocity that indicates whether the fluid flow in a pipe will remain streamlined or become turbulent. So if the velocity is less than the critical velocity, the flow will remain streamlined, and if it is greater, the flow will become turbulent. Equation of continuity. Okay. So let's consider the streamlined flow of an ideal non-viscous fluid through a tube of variable cross section. Variable cross section means, look at here, the area of this look at shape, the area of this end is A1 and the area of other end is A2. So both are different. So that's why we called variable cross section. Note uh, carefully that here we taken streamlined flow. Okay. So let 2 points or 2 sections. First section having cross section area A1 at or we can say at point P, and second Q the having cross section area V A2. Okay. So the according to equation of continuity, A1 V1 A1 V1 rho 1 equal to A2 V2 rho 2. Here rho 1 and rho 2 is the uh, respective density of the fluid. All right. All right, everyone. So equation of continuity is based on the conservation of mass. So it if the fluid which is flowing is incompressible, then rho 1 equal to rho 2. All right. So the equation of continuity is simplified as A1 V1 is equal to A2 V2 or AV equal to constant. All right. So this is a very important relation. A1 V1 equal to A2 V2. Clear? Any doubt here? If yes, write in the chat box. Karthik, Varsha, VK. Equation of continuity clear? The water are flowing from cross section area A1 and exiting from cross section area A2. So in both cases, uh, we can say if we talk about in first and A1 V1 area and velocity V1 is equal to A2 V2. Here mass is conserved. All right. Any doubt here? Any doubt here? Yes or no? All right. So there are three types of energies in flowing fluid liquid. First, pressure energy. So if we talk about the pressure energy, so we can say if P is the pressure of the area A of a fluid and the liquid moves through a distance L due to this pressure, then the pressure energy of the liquid will be work done. So it is equal to force into displacement. So here the formula to calculate the pressure energy of fluid, that is P into AL. Alright. So here the force and displacement right in terms of pressure and volume. Volume is area into L. Okay everyone. Where volume of the liquid is AL. Hence pressure energy per unit volume of liquid equal to P into AL divided by AL. So AL cancel out, the remaining term is P. And if we talk about the kinetic energy, so we can say if a liquid of mass m and volume v is flowing with velocity v, then the kinetic energy will be 1 by 2 mv square. And in terms of kinetic energy per unit volume of the liquid, so it will be 1 by 2 rho v square. So here rho is the density of the liquid and v is the volume. And if we talk about the potential energy, so we know the potential energy mgh. So potential energy per unit volume of the liquid rho gh. Bernoulli's principle. So according to Bernoulli's principle, for steady flow of an incompressible non-viscous fluid through a pipe or tube, the total energy means sum of kinetic energy, potential energy and pressure energy per unit volume remains constant at all points of the flow, provided that there is no source or sink of the fluid along the flow. So we can say here source means that no third pipe should enter from the middle, and sink means that the pipe should not be broken anywhere from which water is leaking out. Only then will we sum of the kinetic energy and potential energy per unit volume and potential energy per unit volume and the pressure energy per unit volume give the same value at this point. So when we sum all three here, so we can say the first side of the pipe is at height h1, look at here, and the second side is at h2 height. So the pressure on the first side is P1, okay, and the pressure uh, on other side is P2. So the area of the first side is A1, area of cross section, and the area of second side is A2. And if the fluid enters with volume velocity v1 and exits with velocity v2, so the mathematically we can write Bernoulli's theorem. It will be P1 plus 1 by 2 rho v1 square plus rho into gh1 equal to P2 plus 1 by 2 rho v2 square plus rho gh2. Now listen carefully everyone. For the examination to solving the questions, you need to remember this formula. Okay, you need to remember this formula. This is very important. All right. All right. So we can also write it P plus rho gh plus 1 by 2 rho v square equal to constant. So or we can say P divided by rho g plus h plus v square by 2g equal to constant. So in this expression, v square upon 2g is velocity head and p upon rho g is pressure head. Okay. So in the Bernoulli's principle, you need just remember this expression. Okay. Okay, Varsha. Karthik? Any doubt here? Yes or no? So firstly tell me who's firstly mark your attendance. Yes, all are present. Tell me, firstly tell me all are present. Then we will move in next slide. Okay, anyone? One. Okay, okay, all right. Velocity of efflux. Now we study about the velocity of efflux. So this word efflux is it means the exit of fluid, that is fluid out fluid outflow. So let's assume we have a tank. Look at here, this one like this, and in which a fluid is filled. Okay, whose density is rho. Now on the side of the tank, here is a small hole. Look at here, this one, small hole. Clear? Which is at a height y1 from the bottom. Now the air above the liquid, its surface is at height y2. Now at what pressure is this? So let's assume it is at pressure P. Okay. So now look at this point here where 1 is written. This one. Okay. This one. So where there is a small hole. So if we look at this small hole, then firstly the water coming out from here, and if we assume its velocity to be v1 and area is a1. Okay, so this opening is connected to the entire tank. So this is the entire tank, and it will have a cross sectional area. So the tank is not a 2D shape, it is a 3D shape. So the tank will be something like this. Okay, so its surface will be something uh, like this. So water will be filled in this manner, and water is coming out of the hole. So the area here, meaning is this area is A2. Okay, A2. So what is A2? This area A2 is on the tank, and the water that is coming out, the area that hole is A1, and the velocity from there is V1. Now since we know the equation of continuity, so V1 A1 equal to V2 A2, and if we want to calculate V2, so it will be A1 V1 divided by A2. So let A2 is greater than A1. Okay, so we assume that or we can say because so A2 is greater than A1. So opening from here tank is also very large. Okay, so opening from where water is exiting is very small, so the upper area, which is A2, is very large in comparison to A1. Therefore we can assume that the A1 by A2 is approaching 0. Okay, so because 0 multiplied by v1 will also 0, this means the velocity v2 will also be equal to 0, meaning the rate of decrease of fluid here, or the rate of fluid exiting from here, will be so slow, that is we can say that it will be approximately equal to 0. So for instance, if there is a very large container with a small hole in it, then the velocity of water from here will be very high, but the rate of water uh, rate of water exiting from the tank will be very slow, the area is very large. That is why it written that v2 is near to 0. This is we have assumed. So now applying the Bernoulli's equation at points 1 and 2, and noting that the whole P1 equal to PA, the atmospheric pressure will have PA plus 1 by 2 rho V1 square is equal to rho GY1 is equal to P plus rho GY2. Alright. So taking Y2 minus Y1 equal to H, we have V1 equal to under root 2GH plus 2 into P minus PA divided by rho. Okay. So when P is greater than PA and 2GH may be ignored, the speed of efflux is determined by the container pressure. Okay, so V1 will be under root 2 into P minus P naught divided by rho. If the tank is open to the atmosphere, it means pressure equal to PA. So in that case, V1 equal to under root 2GH. So this is the formula for velocity of efflux. Applications of on Bernoulli's principle. So the action of carbonator, paint gun, skin sprayer, atomizer, and insect sprayer is the based on Bernoulli's principle. Similarly, the action of the Bunsen's burner, gas burner, oil stove, and exhaust pump is also based on Bernoulli's principle. Motion of spinning ball is based on Bernoulli's theorem. And blowing of roofs by bind storms, attraction between two parallel moving boats moving close to each other, filtering of a flag, etc., are also based on Bernoulli's theorem. Okay. Next is surface tension. So surface tension is a property of a liquid due to which frees, its free surface behaves like a stretched elastic membrane and tends to have the least possible surface area. Okay, so you might have seen a fluid, for instance water filled in bottle or water filled in a glass. So try to shaking it slightly. When you shake it slightly, you feel that it stops surfaces behaving like a solid surface. Or else when you take a glass and keep filling water into that glass, slowly filling water drop by drop, when the glass is almost full, you slowly continue to fill the water, then you will see that if the glass is like this, the water will uh, fill up to a certain height, meaning if you look from the side, the water should be inside the glass, but what happens is due to surface tension, so the shape of the water there becomes like this. Okay, so because an imaginary surface is formed, so the surface tension is the property of liquid due to which its free surface behaves like a stretched elastic membrane, and it tries to keep its area minimum. So the surface tension is defined as the force per unit length. So the surface tension formula is F upon L. Here F is the force acting on the unit length of an imaginary line drawn of the surface of the liquid, and SI unit is of surface tension is Newton per meter or Joule per meter square. It is a scalar and its dimension formula is mt raised to the power minus 2. Surface energy. So, surface energy of a liquid is the potential energy of the molecules of a surface film of the liquid by virtue of its uh, position. This means, uh, as we just mentioned, a particle on the surface of a liquid has an extra energy, which we call surface energy. Why? Because an unbalanced force acts on it due to other particles. So when the particles is in bulk, meaning inside the liquid, it pulled from all sides. But when it comes to the surface, only the neighboring particles put it from one side. So because of this, it acquires extra potential energy, which is present on the surface, and this is what we called surface energy. When the surface area of liquid is increased, work is done against a cohesive force of the molecules, and this work is stored in the form of additional surface energy. Okay, you can understand this like, for example, a drop of water is lying somewhere, and what you did, you spread that water on the surface with your hand or finger, meaning you spread that water on the surface. When you spread a drop on the surface, you also brought the particles inside it to the surface. So the work you did, that is spreading with your finger, you applied energy, and that same energy manifests as extra energy, and because particles move from the bulk to the surface energy increases. So increase in surface potential energy, so delta U equal to work done, which is equal to S into delta A, where delta A is the increase in surface area of the liquid, and work done is blowing a liquid drop. If a liquid drop is blown up from radius r1 to r2, then the work done is in this process, W equal to S into a2 minus a1, and a2 minus a1 is 4 pi r2 square minus 4 pi r1 square. So take 4 pi as a common, so you will be get S into 4 pi into r2 minus r1 square. Okay, so this is the work done in blowing in a liquid drop. Okay everyone, any doubt? Yes or no? Clear? Next is surface energy. So as when we blow a soap bubble, now something interesting happens here, because if you look at a soap bubble, it has a two free surfaces. How? Look, whenever we consider surface area, we look at the interface, meaning where the medium is changing. For example, there is air here, so the interface of this surface means this bubble is made of liquid. This forms one surface between air and liquid, meaning one surface that is visible outside and one surface that is inside this bubble. So if this bubble inflates, the area that is increasing is doubling. If initially its radius was r1, so suppose the bubble was this small, and now it has inflated and its radius become r2. So if we consider area will be 4 pi r2 square minus r1 square, but because at that time there is a one surface outside the contact of air and the liquid, the interface surface area is outside, and One side is also an air and liquid interface, so the area that is increasing will double. So when soap bubble is blown, because it has two free surfaces, so the W equal to S into 8 pi into R2 square minus R1 square. So work done in splitting a bigger drop into and smaller droplets. So work done in splitting a bigger drop into smaller drops means there was one big drop and which was broken into n smaller drops. Okay, so the extra surface area increase because the surface are expanded due to the breaking. This means that when we break a big object into smaller parts, the surface area increases. Volume or mass remains the same, but the surface area increases. Okay, assume radius of a big droplet is having capital R and the radius of small droplet having radius small r. So here r, the relationship between them is r equal to r into n raised to the power minus 1 by 3. So and work done, so W equal to S into 4 pi n r square minus r square. So when we solving this, you will be get 4 pi r square n raised to the power 1 by 3 minus 1. Uh, colli- uh, Collisions of drops. If n small liquid drops of radius r each combined together, so as the form uh, of a single bigger drop of radius r equal to n raised to the power 1 by 3 into r. So in this process, energy is released, and release of energy is given by this one, S into 4 pi r square into n, and multiply with 1 minus n raised to the power minus 1 by 3. Okay, angle of contact. So angle of contact for a given solid liquid combination is defined as the angle subtended between the tangents to the liquid surface, okay, and the solid surface. Inside the liquid, the tangents are drawn at the point of contact. Okay, look at here in the figure. Observe here, tangent is drawn in this way. This is the liquid surface. Look at here in this surface. Okay, and the tangent drawn on the solid surface at the point of contact is what we call angle of contact. All right. If the liquid is like this here, then it is called meniscus. This is a convex meniscus. Uh, so look here. What is this? For example, if this is a beaker, so this is its solid part, and we have drawn a tangent at the liquid interface. So the angle between these tangent is theta. So value of angle of contact depends on the nature of the liquid and solid both. So for liquid having concave meniscus, when adhesive force is greater than cohesive force, angle of contact theta is acute. It means theta is less than 90°. But for a convex meniscus, when cohesive force is greater than adhesive force, the angle of contact is obtuse. That is, theta is greater than 90°. And value of angle of contact theta decreases with an increase in temperature. Excess pressure over a liquid film. So if a free liquid surface film is plane, then the pressure on the liquid and the vapor sides of the film are same. Otherwise, there is always some pressure difference, and following cases arise. So for a spherical liquid drop of radius r, the excess pressure inside the drop P equal to 2s by r, and where S equal to surface tension of the liquid. And for an air bubble in the liquid, excess pressure P equal to 2s by r. Okay, and for soap bubble air, excess pressure P equal to 4s by r. All right. and capillary rise or capillarity. So the formula to calculate the height up to which a liquid will arise in a capillary tube is 2s cos theta divided by rho uh, into r into g. So it will be equal to 2s divided by r rho into g. Okay. Here theta is the angle of contact, depends on the cohesion and adhesion forces. Capillarity is a phenomena, okay, in which a liquid inside a capillary tube either rises or falls when compared to the level of external liquid. Okay. So we know r is the radius of the capillary tube and r is equal to r upon cos theta, radius of liquid meniscus. And tube is rise in capillary tube h is inversely proportional to r. If a capillary tube dipped in a liquid, it's tilted at an angle alpha from the vertical, and the vertical height h of the liquid column remains the same. However, the length of the liquid column L in the capillary tube increases. So the formula L equal to h upon cos alpha. Alright, effect of tilted capillary tube in a liquid is this one. Okay, everyone. Now we will solve some practice questions based on these concepts. So are you ready for the practice questions? Yes or no? Hello everyone. Now we will solve some practice questions based on mechanical properties of matter, and this is question part 2. Alright, this is our disclaimer. So here we will solve some practice questions. So question is if work done in stretching a wire by 1 mm is 2 joule. Okay. The work necessary for stretching another wire of same material but with double the radius and half the length by 1 mm distance is what? So here you have to find out the work done of the second wire. The given options: option A 16 joule, option B 4 joule, option C 1 by 4 joule, and option D 8 joule. So which option is correct? Please solve this question. Firstly, you try to solve this. After that, we will provide the solution of this question. Okay, everyone? Please solve. Yes, which one is correct? Tell me. VK, Varsha, anyone? Karthik, Sumant? Parth? Okay. So the correct option is A. Alright. So here we have to find out the work done. So we know the formula to calculate the work done in case of strain and stress. So W equal to 1 by 2 into Y into strain square into volume. Okay. So here you need to just substitute the values. So initially the work done is 2 joule. Okay. So just put the here. So and 1 by 2 gamma into delta L divided by L whole square into AL. Volume is AL and strain we know change in length divided by original length and whole square. And we will write W as it is again. So it will be W equal to uh, YA delta L whole square divided by 2L. So LL cancel out, the remaining is only 1L. So now work done W prime new work done. Okay. So this is the general formula. So in the second case uh, W prime equal to Y into 4A. Now area is changed in the second case. 4A into delta L whole square divided by 2 into L. L will be L by 2. So solving this term you will be get new work. So W prime equal to 8 into Y into A into delta L whole square divided by 2L. So this is, we know this is what? This is 2 joule. So we can say the work done is 16 joule. Alright. Clear? Any doubt here in this question? Anyone? Yes or no? All right. The second question, two rods of different materials having coefficients of thermal expansion alpha 1, alpha 2 and Young's moduli y1, y2 respectively are fixed between two rigid massive walls. The rods are heated such that they undergo the same increase in temperature. Alright? There is a no banding of the rods. So if alpha 1 ratio alpha 2 equal to 2 ratio 3, okay, and the thermal stress developed in the two rods are equal, then y1 ratio y2 is equal to what? Given option 2 ratio 3, option B 1 ratio 1, option C 3 ratio 2 and option D 4 ratio 9. So which option is correct? Please try to solve this question. Yes. Which one is correct? Anyone? Are you solving? Which one is correct? All right. Let's see the solution. So correct option is C, 3 ratio 2. So the we know the formula to calculate the thermal stress, sigma equal to y into alpha into delta theta. So given that sigma 1 equal to sigma 2, okay. So when the thermal stress of the both rods are equal, then we equate all the given terms. So it will be y1 alpha 1 into delta theta is equal to y2 alpha 2 into delta theta. Okay. So when we take the ratio y1 upon y2, it will be equal to alpha 2 upon alpha 1, because delta theta is cancel out, and the alpha 2 upon alpha 2 or alpha 1 alpha 2 ratio is given, that is 2 ratio 3. So alpha 2 upon alpha 1 is it will be 3 ratio 2. So y1 upon y2 equal to 3 by 2. All right. Next question. The pressure that has to be applied to the ends of a steel wire of length 10 centimeter to keep its length constant when its temperature is raised by 100 degrees Celsius. Uh, for steel, Young's modulus is 2 into 10 raised to power 11 Newton per meter square, and coefficient of thermal expansion is 1.1 into 10 raised to power minus 5 per Kelvin. So you have to find out the pressure. So A given option A 2.2 into 10 raised to power 8 Pascal, option B 2.2 into 10 raised to power 9 Pascal, option C 2.2 into 10 raised to power 7 Pascal, and option D 2.2 into 10 raised to power 6 Pascal. So which option is correct? Please try to solve this question, everyone. Yes, which one is correct? Please try to solve. Let's see the solution. So correct option is A 2.2 into 10 raised to the power 8 Pascal. So look at here. The rod having length L equal to 10 centimeter to keep that is constant. So when pressure is applied, so we know the thermal stress that is given by sigma equal to y into alpha into delta T. So here it will be equal to the pressure applied or needed. So just put the all given terms here, and you will be get pressure equal to this one. So we can say pressure equal to 2.2 into 10 raised to 11 Pascal. This is just mathematical calculations. When you do calculations, you will get the final answer. Okay. Listen, everyone. In the examination, you need to just do your do your calculation part if you know the concept of the question. Okay. So these questions work as a booster. So you need to try every questions one by one. Next one. A metal rod of Young's modulus Y and Young's coefficient of thermal expansion alpha is held at its two ends such that its length remains invariant. If its temperature is raised by T degrees Celsius, the linear stress developed in it is what? So here you have to find out the linear stress. Okay? Please solve this question. Which option is correct? A, B, C or D? Yes. So correct option is C. Y gamma alpha into T. So we know change in length delta L equal to alpha into uh, L into delta T, or it is also equal to FL divided by A into gamma. So stress is equal to force upon area. So just put the value of force and area and rearrange it. You will be get gamma into alpha T. Okay. A wooden block of mass m and density rho is tied to a string. The other end of the string is fixed to the bottom of a tank. The tank is filled with a liquid density sigma, which sigma is greater than rho. The tension in the string will be what? So here you have to find out the tension. So which option is correct? Option A, option B, option C, or option D? Please try to solve this question, everyone. Which option is correct? So let's see the solution. So from the free body diagram of the wooden block, here tension is vertically downward mg and v sigma rho acting vertical. This force acting vertically upward. So the total force we can write v sigma into g equal to mg plus t, where v is the volume of the block. Okay, so we can write it t equal to v sigma g minus mg. So just put the values, you will be get m divided by rho into sigma into g minus mg. So it will be mg into sigma minus rho divided by rho. Okay. Clear? One last question of the today's lecture. Question is, a ball is made of a material of density rho, and where density rho oil is less than rho and less than density of water, with rho oil and rho water representing the densities of the oil and water respectively. The oil and water are immiscible. If the above ball is equilibrium in a mixture of this solid and water, which of the following pictures are represents the equilibrium position? So you have to find out the correct one. Yes, please try to solve this question. This is a theoretical question and very easy. So correct option is B. Since density of water is higher than oil, so water will be on lower side of weaker. Also because density of oil is less than density of ball is less than density of water. All right. So ball will sink through oil but will not sink in water. Therefore, ball will stay at the interface between oil and water. Look like this. Okay. Clear everyone? Yes or no? Thank you for your attention. That's all for the today. Thank you.